and run and install npm. And then we're going to ls in our downloads, and we're going to change directories into Juice Shop. And so we'll cd into our Juice Shop folder. And every time you run OWASP Juice Shop and you want to open it up and you want to practice in this vulnerable web app, you will have to cd into your downloads and cd into Juice Shop, because when you spin up your server, it is going to spin up whatever content is inside the directory that you're inside of. And so now to start npm, we just type npm start, and that will go ahead and spin up our server for us. And it now says our server is listening on port 3000. And then we can come back to our search engine, and you can type, this is what we'll be typing in, just localhost 3000. And you'll type that into your browser, and this is now our vulnerable web app that we're going to be practicing on in the future lessons. But before we get to practicing and seeing what we can manipulate and what vulnerabilities we can find, I want to walk us through a little bit of what we're going to be looking for and how to identify different vulnerabilities and how we're going to use burp to help us find them. But you will notice that if you have burp running and you turn your proxy on and you start clicking on things and you refresh the page, burp is not intercepting anything. It is not working for us. So we need to configure our traffic so that it goes through our proxy. And we're going to do that by going over here, opening a new tab. We will type in about config and hit enter. And I will warn you to proceed with caution, because this will change how your browser functions. So you want to accept the risk and continue. And we are going to type in network dot proxy, and this one right here, allow hijacking localhost. We'll click this, and we need it to change to true. And then we can go ahead and close out of this tab. And now if we refresh our page, you can see that our traffic is running through burp, and we are able to intercept the requests. Okay, in the next few videos, we're going to be going through a couple of different PowerPoints. The reason for this is I think it's really helpful for us to have some kind of foundation before we begin looking at examples. I think by the time we get through the PowerPoints, you're going to be a little confused and probably still not know what exactly we're looking for or what's going on. But my hope is that with the PowerPoints and then just a couple of examples, you'll be able to start finding some of these bugs on your own. And we're going to be practicing on Hacker 101 as well as Juice Shop, which we just downloaded. And we're going to be looking at how to use burp before we begin looking at trying to exploit some of these vulnerabilities. I think that you will be using burp a lot, and so it'll be helpful to go through and kind of look at how it works and explore just a couple of its functionalities before we begin our exploitation of some of these vulnerabilities. And so we're going to be looking at IDORs, business logic errors, and we are also going to be looking at manipulating user input and cookies and tokens as well as we continue in this course. And so we're going to begin by looking at insecure direct object reference. These are called IDORs. That really doesn't tell us a whole lot, but they're really simple to understand once we get going. These IDORs are going to be just parameters that we can change, so that we can bypass specific functions on a web app. With IDORs or business logic errors, you can bypass payment options, you can reverse payment options so that you're the one getting paid, you can put things into other people's carts. There's a lot of different ways you can use IDORs, and when you're out hunting on your own, you're going to have to be creative, because there are many different ways that you can exploit IDORs. You can skip login pages, you can access someone else's account. I personally, one of the first bugs I ever found was being able to write on someone else's social media platforms. It was actually just one platform, and there was just one specific area of the web app where I was able to change an ID and write on someone else's wall of their news feed. And so that is an example of an IDOR. You can also leave feedback on someone else's under someone else's name. You can edit another person's blog or their post. And so these are just examples of IDORs and different ways that you are going to be able to find them. And IDORs and business logic errors are going to be the most common bugs out there, which is a great thing because it makes it easier for us to find them, and they are easy to find as well. And so these are something I think we should learn very well, and we are going to have a significant amount of time to practice these because there's actually a lot of different areas and ways to practice these, especially in JuiceShop, which we just downloaded. The best way to test for these, and I think the only way, is by creating 2 different accounts. It is always good to create 2 different accounts because you will have to test in real life against your own accounts. You cannot test on someone else's account. So you can't write actually on someone else's wall. This would be out of scope, or you can't leave feedback as a different user. These will always be out of scope. You don't want to ever mess with the functionality of the application or the people who use it. You will only use your own accounts to test against, and it also makes it easier to use your own account because you already have a second ID number that you can use on your attacker account. So you'll have an attacker account and a victim account that you will use. And so you don't want to test on someone else's account. An example, or a simple example to remember, is to look for hidden inputs. You'll actually see this as well in Burp. When you create an account, it won't say input type hidden, but you will see such as a name and your username, and it will say, are you an admin? And then it'll say value no. An easy way to show one of these errors is just to change this value to yes or true, and you will automatically have admin privileges. And we're actually going to be able to test this out in JuiceShop, something just like this. So you'll get to see this in action. And so we're always looking for parameters and things that we can change to get us somewhere that we should not be. One of the other places that you will find IDORs is in cookies. A lot of times cookies and tokens will host user information. So that's how websites will keep you authenticated. Not all of them, but some of them will be through cookies. And so you will have inside cookies, maybe you'll see something in your cookie like user ID and then a number. And you can change the number to something else to see if you can access that account. For example, if you had 2 accounts, you'd take the user ID of your victim account and you would replace it on your attacker account and see if you can access parts of that application that you shouldn't under another user. If you were getting malicious with this, you would change the value to 0 or 1 and see if you could gain admin privileges to the web app. And another way to test for this is to see if you can log in, save your cookies first or your tokens, and then log out, and then see if you can log in and delete your previous cookies or tokens and then repaste in your new ones and see if they have been terminated or ended. If they haven't, this would be a logic error, because when the session has ended, so should the cookies or tokens. And so you can see what to manipulate and where you can manipulate different things within cookies and tokens as well. These aren't specifically IDORs, but they're similar. They're similar enough that I think they can be included together. And so when we're testing, we're going to be using Burp. This is going to be where we're at the most. Sometimes you will be able to see these in a URL. For example, if we have this example here, www.website.com, and let's say you have an invoice, you just purchased something, and it says your invoice number is 12. In a URL, you can just change this 12 to an 11 and see if you can access another customer's invoice. And if you could, this would be a sensitive information disclosure. It's something you shouldn't be able to access. And that would be a simple IDOR. I think they're easier to test for in Burp because it's all laid out for us, as we'll see in the coming videos. And so also another example would be you can upload images or resumes, like on Indeed you can upload a resume, and you can see in the URL if you pull your resume. So let's pretend this is Indeed and it says www.indeed.com and then it's got a slash and it says resume equals 87, and that's your resume. You could change this and see if you could access someone else's image or resume just like you would have with the invoice and see what you can access. But remember, out in the wild we are testing our own accounts, and so I actually have an example here for us. I pulled off of HackerOne of an IDOR that somebody actually has found, and so we'll walk through exactly how he pulled this off. And so he goes to the website, remember, creating 2 accounts. He has a victim, logs in as the victim. He creates a blog on the site, he saves it, and then what he ends up doing is going into the victim account or the attacker account, and he does the same thing, makes the blog, and then from there he clicks the save button and then goes to the edit user profile and saves it, opens up Burp, and then what happens is he can change the ID with the victim's ID, and this would be a clear IDOR accessing something that you shouldn't be able to. And we've seen things similar to this with the URLs earlier in changing URLs, and then he forwards the request to go to the victim's account and the website information, and you can see that it has changed. And so this is an example of an IDOR. I think we'll be able to make this sound a whole lot easier once we're actually walking through them. And so I want to go and talk a little bit more about cookies and the URL and what exactly we can do with them. Then we're going to look at how to use Burp to find IDORs, and then I want to turn you loose and let you try and find an IDOR on your own. In this video, we're going to talk a little more about URLs and what we can do with them, cookies and tokens, and then we're going to look at something called CyberChef, and then we'll move into Burp and exactly how it is going to help us in its functionality. But before we get there, I was talking with my wife and I just said, hey, I think I'm gonna have to warn that my PowerPoints are going to be full of errors because I actually made them just for bullet points for myself, and I was going to keep them on my second monitor, and then I realized I didn't have anything to show you and I wasn't just going to have a blank screen. So if you're wondering how can somebody with a PhD have such poor quality PowerPoints, they were originally just my notes, and so I decided rather than sit here and comb through them and go back over it, I will just show you. This is basically what my notes look like when I take notes, and walk you through them just so we can have a better understanding of a few more exploits before we move into Burp. So first, changing passwords. You will actually come across this in JuiceShop when we are practicing, and more as we get further into the course. Sometimes you will see a URL that looks similar to this, or in Burp, it will pop up at the bottom of a post request, and we will have something similar to this, like a change password. You will have the username, and then the new password will be stored right here. And in something like this, you could actually grab someone else's username and on your victim account, try and change the password to it and see if you're able to pull that off. Or you can go ahead and see if you can maybe delete your victim account by, instead of having change password, you'd have delete account or delete user or just delete, and then you can put the username here and you would obviously not have the password. You will also in Burp be able to have delete instead of you'll have put, post, delete options, and you can try and delete the account through Burp. And if you are unable to, even if you aren't able to pull any of that off, if you have a URL that has a username and a password in it, even if it is encoded with something as simple as base64, this would be an information disclosure. And we'll get to why this would be an information disclosure in just a few slides. We talked about this a little bit in the last PowerPoint, in the last video. If you have a website, something similar to this, which I actually just copied this out of the OWASP guide, and the OWASP pen testing guide, as well as another image that we're going to come to here in a second. Sometimes you'll come to something like this. If you are logged out and you copy and paste in a URL that requires you to be authenticated, and it says authenticated no, and it does not allow you to view the site, you can just change this authentication here to yes or true and see if you are able to access the site and see what you can gain access to. And then we can check the logout functionality. And this is why it is an information disclosure if you have a username and a password in the URL, because it is possible for you to log out on your computer and then close the browser, and you'll be able to open up the browser and it has cached the previous page that you were in, and you can go back into the history and open that page. And if it opens, even if you're not able to go to any other links because you're not authenticated anymore, but if it opens that URL and your username and password is in there, it would be an information disclosure. Or if you log out and you don't close the browser, it's possible to hit the back arrow or the back button and go to the previous page and have the information there. And this can also be more than just information disclosure. If you're able to hit the back button after you've logged out and then browse the site again and it re-authenticate you, this is something that's listed in the OWASP guide. It's something that happens. It's not very common, but it's something to check for. And you might be thinking this isn't a very big deal, because that's what I originally thought I was. Okay, we are going to, in this video, go through some of the functionality of Burp. And so I'm going to go ahead and have you navigate over to Hacker 101 and get into their CTF. And we're going to open up Postbook. And you can go ahead and click go and pull it open. And when you're there, the first page you'll come to will look like this. And so we'll go ahead and come over on Burp. You can turn your intercept on and make sure that you are sending all of your traffic through your proxy by coming over here. We'll go to Preferences, scroll down to Setting, and make sure that you have manual proxy configuration, and then it looks like this. And once you have that done, you can click OK, and your proxy should now be set up to intercept your traffic. And just to give it a test, you can refresh the page and make sure that it pulls through here, and you can forward all of the requests we intercept, or you can just turn it back off and then turn it back on. But we are going to come in here and we are going to sign up. And so we'll go ahead and click sign up, and you can just see what's going on in here. We have our sign up.php. You can see it's pulling that from our URL. We have a GET request. We'll forward that, and we'll come back over here, and this is where you're going to make your username. And we can just type in test, and password can be test, and you can submit your query. And then in here you can see your username and your password. And if you wanted to actually try and mess with this and see what we can do with it, we would send it to Repeater. So you just right click and click send to Repeater. And over here, we can send this request as many times as we would like to. And so in here, we can change the username and click test1 and then send it. And we are getting a 302 in response. So let's go ahead and shut this off and see we have successfully signed up. And I think we actually created the test1 account as well. Yep, so we have made the test account and the test1 account. And while you're in Repeater over here, you can see that this would be not a very secure way of submitting these things. You will actually come across this pretty regularly, even on large, very common websites. And you can see what you can do here. You can try and manipulate things and see just what you can do, and maybe type a GET request and change to a different URL and see what response you get over here. There's lots of things you can do. And in Repeater, you can send this as many times as you want to the server, and really just try and figure out if you can get anywhere that you shouldn't be with this. And so we're going to go ahead and come back to our proxy, turn it on. Now we are going to just create a post. We'll go hello world, create post. We have a user ID of 5, and remember, every time we see ID, we should be thinking IDOR. What can we change? Where can we go? What can we get with this? And we have the body of the message over here. We have a cookie over here. You could bring this over to CyberChef and see if maybe there's anything in there. If you remember, we just go magic, and then we would paste it in, and you could see we didn't get anything out of our cookie, and so that's okay. We would come back here, we can send this to, it says we get a redirect, you can follow the redirect, and then come down here and see what your response is, and it says we need to sign in. So you have to be authenticated, so the cookie is necessary, something that we have to have in order to continue on for authentication purposes. But as you can see, this is kind of how I would just go about testing at the beginning. Just see what I can do with this ID, what I can do with burp with body, see where I can get, where I can go, see what responses come back. And with that, I think I've given you a pretty good clue here with this user ID. There is an IDOR in Postbook. I'm going to give you the challenge now to open up Burp, come in, make an account or 2 accounts, and see if you can find the IDOR. Before we go ahead and solve this challenge, I want to introduce you into one more functionality inside Burp that is going to be helpful in the future as you're doing bug bounty hunting, and that is the intruder. So right here in intruder, one of the things we could do with intruder is as we come in here and we just refresh this page, we have this ID of 6. Let's say there are 1,000 different numbers in here. What you can do is send this to intruder, and it will actually go through these numbers for us. So you can come over here and you can go to position, and we will clear this, and you'll highlight this number 6, and what it does is it will go through every number we specify in here and replace that number 6 and then give us back the response. So we can come over to our payload and we can go simple, we can do a simple list, and then we will put in just numbers. We'll do 1 through 10, so you just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we have just a simple list, and we have just the one position, and we're going to go ahead and run through these numbers. And so what you do is you click Start Attack and go OK, and it will automatically replace that for us. And then we can click on these and see what we have in the response. And you can come through and see if we have found anything in here. It says write a new post, my profile. It doesn't look like anything private. This is for my own eyes only. Number 2, and we see the same thing. And this one actually has someone put in actual content, and then you can go down to number 3, and you can see how this would make it easier. So you don't actually have to go through and do 1, 2, 3, 4 manually. You can, but you don't have to. And so what we would do if we wanted to get more malicious with this, as we're looking for an IDOR, we can come back into our proxy here, and you can turn it off, or you can use Burp. I'm going to use the URL just because it's what we're used to, but I would encourage you to actually try this with Burp. I'm going to show you how I would do it with the URL, and then you can actually come in here and see if you can run this exploit and find the flag with Burp and without using the URL. And so what we do is the exact same thing. You can come in here and you can just go 1, and then somebody posted this. It's not private, it's to the public, and you can come here and you can type in 2, and this actually has the checkbox. Yes, this is my own eyes only, and so this would be something that is not supposed to be seen by everyone, and so this would be considered an IDOR. If this was an actual program, you could report this as an IDOR, and not only that, you can write inside someone else's entry here, and then you can save the post. And in saving the post, I am not actually sure why There are two flags, maybe one for writing on someone else's wall and one for the iDoor. I'm actually not entirely sure, but you can see the author was also an admin. So we made it beyond just a regular user and into an admin. And so this is how iDoors work. We're going to be moving from Postbook into JuiceShop. And the way I want to work through the JuiceShop vulnerabilities is by giving you just little hints, maybe telling you what part of the application there is a vulnerability, and then setting you free. And after you have spent a significant amount of time and you're starting to get frustrated or you want a clue, just continue watching the video, and I'm going to work through some of these vulnerabilities step by step. But I want you to give it a shot and try and figure out where the vulnerability is and see if you can solve the challenges on your own. And only if you're really struggling, come back and get another clue and then pause the video again and see if you can figure out the rest of the challenge on your own, kind of like we have been doing. But from this point on, it's going to be a lot more difficult for me to show you very specific vulnerabilities on multiple websites, because at this point, JuiceShop is going to be our main place of working, because there's not a whole lot of options when it comes to practicing specific vulnerabilities and then me showing them to you. So I want to give you clues of where they might be located in the application and then set you free to try and exploit them, and then only when necessary help you with another clue. And so with that, you can actually continue playing around in Postbook and see just what else you can do in finding iDoors. Okay, we are ready to find our first iDoor on our vulnerable web application. So you can come in here and try and find it on your own, or I can give you a tip on how to get started. If you want to try it completely on your own, you can go ahead and pause the video now, browse the application, intercept your traffic with Burp, and see if you can find the iDoor. Your first tip is going to be, we'll find the iDoor in leaving customer feedback under someone else's user. So you can go ahead and try and find that now if you want, or keep playing the video for the next tip. Okay, the next tip is going to be creating an account. I already created one. I figured you didn't want to sit through me creating an account, so you can actually just come up here, click on the account setting, the account tab, go to login, create a login, and once you're logged in, try and find how you can leave feedback as someone else. We are going to go ahead and solve this challenge. If at any time you feel like we have gone far enough and you have enough clues, you can pause the video and try and solve it on your own from that point forward. But we're going to come over here to this menu. We are going to click customer feedback. Now, I want to give you another helpful tip. If math is not your strong suit, you can actually open up and inspect the element. You can come to network, and then you can refresh this. And in our network, we will get a whole bunch of GET requests, and we will look through and find the one. Since this is called CAPTCHA, we're going to find the one that is labeled with CAPTCHA, and in there it will have for us the answer. And you see this request. We are going to look at the scoreboard at the end of this video, and I'll kind of talk through what this is, but we're going to go to this as soon as we solve this iDoor. But as we continue scrolling through and we're looking for the CAPTCHA right here, you can go to the response. Our answer is going to be 11. So it will solve for you whatever math problem you have. And that's the easiest way to get through these. And so our answer is going to be 11. It has our username. We can leave a comment. I like to just leave hello world. We will give it a rating, and then make sure to intercept when you submit this. And so we'll hit submit, And now we have our user ID. If you want, you can go ahead and pause the video and see if you can figure out what to do from here. What we will do is we're going to send this to the repeater. We can come up here, open it up. We can send this request to make sure it goes through. It says it was created, so we have successfully left feedback. But we want to leave feedback as someone else. And so what we do is we can change our ID to, let's just go 14. Just pick an arbitrary number that's less than the one we were using or the one we were assigned. And then we can send it, and it says it was created. So now we should be able to turn off our proxy intercept, come back to our web application, and it tells us we successfully solved the challenge of forging feedback. So this is an example of an IDOR where we are leaving feedback under some other user's name. And now I want to go to the scoreboard real quick. This is where you can see the challenges, and you can see all of the challenges that are available on this web application. All right, I was playing around with the comment section in the products, and I realized you can actually leave feedback as someone else other than coming over here to our customer feedback. You can actually leave feedback from a different user right here on these products, and maybe you actually figured that out in the last one, and if you did, that's awesome. And if not, you can go ahead and try and solve this challenge on your own, and then we will go through it together. So if you want to give that a shot, you can go ahead and do that now. Okay, we are going to just open up one of the items that already has a review so that we have a name that we can leave feedback under. And what we'll do is come over and turn on our intercept and type in some kind of message, and then we will submit. We'll come over here and see if we can find it, and here it is. We can send this to our repeater. You can come over here and send this, and it says it was created. So we have the message, and then we have the author. So instead of having our name in here, we can put in Bender at Juice Shop. Was it dash? I think that is how it was written. And then we should be able to send this, and we'll actually just put in something else here and send it, and it says it was created. We'll turn the intercept off, and you can see here it was created under someone else's name, and it actually says we have successfully completed the challenge again. Okay, our next challenge is going to be one that we have talked about, but we have not actually seen, and I have not come across any vulnerable web apps to actually test this on and show it to you, but we have talked about it, and you might have to use some of your Googling skills, or just if you get stuck, follow along with the video and get a hint before you move on. But we're going to create an admin account, and this is something that is very possible that you will come across. It's not very common, but it does happen that you can find ways to create an admin account or escalate your privileges. So we're going to go ahead and make sure our intercept is off. And what I need you to do is go ahead and create an account and see if you can figure out how to get the account enrolled as an admin. And so you can go ahead and try that now. I think what I will have to do is log out, and I'm going to make a new account just the same. And I will come in here and go not yet a customer. This time we'll go John at john.com. And as soon as you get this done, we will turn on our intercept and we will register the account. Now what we're going to do here is we're going to send this to Repeater, and over here is where we'll work on escalating the privileges to an admin. So we'll send this, and just to get a response to see what we have here. So our role is a customer, and this tells us that we're going to need to change the role. And so I actually just did this a few hours ago. I was just working through the application, and I'm going to show you exactly what happened to me, because this will give you a really good idea of just the trial and error that we go through when we're testing applications. So I came in here, I typed in role just like this, and I typed in admin. And if you send it, since this user has already been created over here, we're actually going to have to change this to 1. And if we send it, we can see we've now created another user, but the role is still customer. And so I changed this to administrator, and it still didn't work. So I tried to change this to user admin, and then change this over here again, and we are still a customer. And I've tried user, I tried admin, I tried administrator, and finally what happened was I deleted this and I came up here and I tried to just move our input to see if that would make a difference. And I typed in admin, just the same as before, and that looks good. And we'll change this to a 3, and then we will send it. And now you can see our role is now admin. So we have created an admin user. So if you take this user with this password that you just made, you can log in and browse the JuiceShop application as an admin. And so you will actually see things like this in the wild. They're uncommon. You can actually go on HackerOne and read the hacktivity and see where people have actually got this to work. And you can see, just read the articles and read the submissions to observe how people have pulled this off. Some of them are going to be more complicated than this, but some of them really will be this simple. Okay, what I need you guys to do for this next lesson is go ahead and open up a new tab, and up here we're going to go to Portswigger, and you can go ahead and search for it. It should be the first one, and we're going to open it up, and we're going to move over to the login button. I've already created an account, and so go ahead, click on login, create an account. We're going to need it, especially in the coming lesson. So go ahead, click the login button, make an account, and I'll see you once you're logged in. Okay, once you have reached your login page, go ahead and click on Academy, and then go to All Labs. And once this loads, we're going to go ahead and scroll down until you find Business Logic. And I believe it's pretty far down in all of these labs. And so scroll down to our Business Logic errors, vulnerabilities right here. And we're going to be working through these right here. And so let's continue going forward. So these actually say solve because I already made the videos for these, and I realized that I never actually explained how you guys should get here and get to these labs before I started filming these videos. So I'm going to edit the video, and these are going to turn into unsolved. Okay, we are going to look at a few business logic vulnerabilities. And so these are very similar to the IDORs that we have been looking at. And so we're going to go ahead and just start here with this one right at the top. So you can go ahead and click on it, and we can look and see what exactly they have for us. And it says that it doesn't validate user input, and we're to buy this lightweight jacket. So you can go ahead and open up the lab, and this is where it brings us. It said we needed to log in, so we will go ahead and do that. And it gave us the login credentials, so we'll log in. And now we are supposed to buy this jacket. So I guess we can go ahead and view the details and add it to the cart. Let's actually come in here, turn the intercept on. We'll add it to the cart, and it tells us our price right here. I don't know exactly how much we're allowed to spend, but I think we should be able to. Let's see if we can make this a negative number. And we'll go ahead and forward that, and then we'll just turn that off. And it did not add it to our cart. We have $100 to spend on this jacket, and this jacket is way over $100, $1,300. So we'll go ahead and see if we can turn the intercept on, add this to cart, and let's just change our price here and see if that works. Okay, we're allowed to add it to our cart. So we have no need to apply a coupon, and we should be able to place our order. And it says we have solved the challenge. So things like this and business logic errors, IDORs and business logic errors, they're going to be things that you have the opportunity to find. These are pretty common that you'll find these business logic vulnerabilities. They happen when developers get lazy or they're just not really paying attention to what they're doing. I've actually seen really advanced developers make very simple mistakes that made their web applications vulnerable just because they weren't paying attention. And so you can find these. They're pretty common. I know there's at least one bug bounty hunter that this is all they do. They look through Burp, they look for business logic errors and what they can change just to find stuff that they shouldn't be able to. And vulnerabilities, these are pretty simple, and they do take a long time to find, but you can find them just by doing really simple things, by just changing numbers and inputs. Sometimes you will find stuff that has been encoded. It'll say, like, you'd have the lightweight jacket. Let's actually go back. I'll just show you. Sometimes we will add things to our cart like this, and you would have this, it'd say price, and it would look like this instead. We'll encode it, base64. You'd have this sitting inside your price instead of that number. And so what you have to do, if you see something like this, you'd have to take this and you'd come to your decoder, or you can go to CyberChef and you can put it in and try and decode the price. Rarely going to see it where it's just a plain number, but this is way more common that you would just see a number here and that you would have to decode it. Sometimes these prices will be stored in places other than just something plain and simple like this. And so it's something that you're going to have to look for and poke around. They do take a while to find, but you can find them right off as a beginner who knows very little. And we're going to look at one more, and then I want to send you off on a challenge and see if you can find a business logic error on your own. Okay, we are going to continue with the business logic vulnerabilities. We're going to go ahead and open up the second one, and after this one I'm going to set you loose on a challenge. So what we'll do is we'll go ahead and open this up. It looks like the same as the one before. We need to buy this jacket, and we have our login user right here. So we'll go ahead and log in, and we'll try and proceed with buying the jacket. Okay, here's our jacket. So we'll go ahead and view details. We'll add it to the cart. We're going to do the exact same thing we did in the last one, and I'm going to do it the exact same way by starting out. Oh, we don't have a price. So we got our product ID, our product, and here's our value. Let's get 2 of them. And I'm assuming we have the same amount of money in our card as we had the last time to spend. So we'll go ahead and just put the negative sign in front of the 2, and we'll see if it allows us to put in a negative number. And we were. So in our cart, if we go look at it, it says we have negative $2,600. That means they are going to pay us. See if it'll go down by using these buttons. It does. So you wouldn't even have had to have done this in Burp. You could have just come over here and click this button, and it means they're going to pay us this amount of money. So when we place our order, we're definitely going to be able to buy our jacket, and our store credit is going to increase. Our price is not allowed to be less than 0. At least they have that in place. So we'll go ahead and, okay, made our cart empty. We're gonna have to go back and put that back in our cart. So what I think we'll do is we'll add this to our cart as well. I'm not sure how many of these we're gonna have to add. We'll go ahead and add one in, so that way we can buy our jacket, because that is our challenge. We'll go ahead and make sure that's negative. Forward, turn that off, and now we should have 2 negative items in our cart. It has to be above 0 but less than 100. So what we can do is we can just continue to subtract these. Oh, we'll add these. We'll go ahead and add these until we hit our price. Okay, it went back to 0 and removed it from our cart. So we'll go back over here. Back over here. Let's find something a little more expensive so we don't have to add that so many times. We'll go with the pool. Come to Burp, turn our intercept on, and this is exactly how this would happen if you were testing it. It's just going to be a lot of trial and error. We're going to need, I'm going to guess, at least 15 of these. We'll just go ahead and add them to the cart. We don't need to intercept that. And go back to our cart, and there our total is now $76. So what we did is we just added 15 of these pools, which got us close to $1,500, and then $1,500. And then what we did is we went ahead and added our jacket in at a negative price because it wouldn't let us purchase anything at a negative number, and we only have $100 to spend. And so this should solve the challenge this time. So we'll go ahead and place our order. So I just wanted to add that you saw me make a lot of mistakes and a lot of trial and error in this video, and I want to thank you for being patient, but I also decided not to edit out all of the clicking that I had to do and the failures from this video, because I wanted you to see what it's realistically like as you test web applications, and as you're on the hunt, you will be doing what I just did the majority of your time, just trying to see if things work, and as they fail, you just go on and you try something new, and you try a different way to try and exploit the application or the vulnerability. And so I want to just encourage you that as you become frustrated or things aren't working, to just keep pushing on and see if you can find that vulnerability. Okay, it is time for your challenge. So if you navigate over to Juice Shop and get it running, what I want you to do is try and solve the challenge to where you actually are being paid $200 or $300 or $400 or more from this application. We just worked through 2 labs that are similar to this. So you can go ahead and try and solve this challenge, and when it's done, you should get the green bar at the top of your screen that'll tell you that you have completed the challenge. So I want you to go ahead and pause this video and give that a try. Okay, how did that go? We're going to go ahead and walk through this in the same manner in which I would solve this. So go ahead and add something to your basket, and then we'll check our basket. And then at this point, what I would do is I'd go ahead and turn the intercept on and walk through the whole checkout process and see if there's anywhere that I am able to modify. and see if I can modify this in any way, shape, or form. And what I think I'm going to do is I don't actually want to walk through and have you watch me put all of that information in just to solve this challenge. So we'll go ahead and see if we can actually modify this before we get there. So it says we have basket ID of 5. We're buying product number 4. Let's see if it will let us do what we did in the previous challenge and put in a negative amount. So try 99, turn the intercept off. It says we were able to add those to our basket, and they're gonna pay us. That didn't work. Okay, they're gonna pay us if we do that. So we'll go ahead and we'll try that again. $100 wasn't enough, so we'll come back to our products. We'll add to our basket. I forgot to turn burp on. We'll add this to our basket. We'll forward. Here's our quantity. I wonder if the rest of our content's at the end of this string. Well, we have our quantity, so what we'll do is we'll type in negative, and we'll do 200 this time. And we'll forward that and go to our basket, and that's more like it. We're gonna get paid $400. So what you do at this point. So for the next few minutes, I'm gonna show you a little bit of a walkthrough and explain SQL injection from the Nodus website. And I don't want you to actually go there or try and do this walkthrough. We're gonna have plenty of practice when I have you create an account with Portswigger and we walk through the Portswigger SQL injection labs. And so for just the next few minutes, as we go through the Nodus example, and then I'm going to show you what the code actually looks like in a MySQL database. And I actually wrote a React app that's hooked up to a Node.js backend with MySQL as the database, so you can kind of see what the code looks like. Not that you need to memorize it, but it might help a little bit. Then we are going to move from there into Portswigger and try to walk through the SQL injections together. So for the next few minutes, as I am on the Nodus website, just try and follow along and maybe catch a few nuggets of detail to understand. And then as I walk you through the actual back end of a SQL database, I hope that you can understand it and maybe even do a few of the Portswigger walkthroughs with me, and then come back and then watch the MySQL database explanation again, and hopefully it will begin to click. This is one of those attacks that is really common, and so it's something that you should know. And up front, I'm just going to tell you, it might take you watching this and going through these labs several times to fully grasp the SQL injection, but that's okay. It takes time to become an ethical hacker. So with that, let's jump into it. Okay, we are going to begin working through some SQL injection. This is something that you can find. There are bug bounty hunters that dedicate their time only to looking for SQL injection. So if this is something that you find interesting, you can become really proficient at it, and this can be something that you primarily search for. So this is something I suggest learning, and learning well. It's easy to look for. You don't really need to know a whole lot about SQL databases in order to find these, but it does help. In the bug bounty world, it's actually a lot easier than if you find these on a capture the flag, because all you have to do is put in a time delay to have a proof of concept. But in a capture the flag, you'll have to know a little more than what we're going to go over here. But for the sake of not going through and learning how to program in SQL databases, I think it would take just too much time. And so we're going to go through how to find these if you were to start looking on bug bounty programs. And I went ahead and opened up Nodus 15. You don't have to go through this or work through this. I'm only going through this to show you what it's going to look like, and then we're going to actually go over to Portswigger and we're going to work through their practice SQL injections. And so just to give you an idea of what we're doing, when you come to a login form such as this one of the best things you should do and you should regularly check for is just to put in a single quote, and then you would hit enter and see what happens. And it says this user does not exist. What we're looking for is an error in the query. So I would go and I would do a double quote next, and I would hit check existence. And if you can hit an error, this is what we're looking for. And I'll actually show you in Burp because this is where you're probably going to be sending your request through. So you'll hit check existence. You would send this to your repeater. And I'm actually just going to go ahead and change this so you can see it. And then you would hit send. And it says we get an error in query. What we're going to see here in a little bit is we're going to see this be a 501, an internal service network error. And that's usually what you'll see. Start finding these, but you will find what is called a blind SQL injection. We're going to look at those a little bit later. So we still have the error. So what do we do with the error is we're going to start the enumeration process, but we're actually not going to do that here. I just wanted to show you kind of what we're looking for here so that you can look for it on your own in the first Portswigger lab and see what you can find if you can find it on your own. But just to give you a little more of an idea of what's going on in the background, the SQL database and the SQL language is going to look something like this. Select all from users. This will be where username equals, and this is what we input right here. So this would be our input. So what we did is we took this. This is what it'll look like. And this is what we can put in here. So you'd put your single quote or your double quote. And in the case of the Natus web application, what it has is something like this. And then here's where you're putting your query, where you're putting in to see if the username exists. And so when we put in another double quote, what happens is you break the query and this produces the error right here because it doesn't need to be there, it shouldn't be there in order for this to work in programming. And so that's how you break it. Okay, what we're about to go over is going to be a little advanced, but I think it will help you visualize what's going on beyond more than what I just showed you in the last video. So what I have up is actually MySQL Workbench. We have here just a simple database username I was testing. Here's an actual username and password. This is what a table will look like. And so in our query, we have select all from users, which is our schema, and then the table, which is users that's not capitalized letter here. And so this is what a table looks like. And what's going to happen is this is running on a server, and when we send a query to the back end of a web application, it will reach out to the server and see if our query is true. So I want to pause here because so this is an update. I want to pause here and explain something a little better that I noticed I didn't do a very good job of. When you make a query to a database, the whole reason I wanted to show you the workbench is so that you could see these are the tables. So if I came over here and I said from select all from blog post, then we're going to be grabbing the tables from inside the blog post. And so when we look at this, select all from users, this is showing all the databases. So this is a database, this is a database, and we're selecting from this database right here, the users table. So the first one that we see right here, this is the database, and this is the table within the database. So select all from database and then table. This will be really helpful in the future when we learn to run SQL Map and we need to know the context of SQL Map. And so this is what it will look like, the code will look like. We have our database and we're querying our database and we are selecting all from the users table where the username equals, and then you can just pretend this is blank because this is where our input is going to go in here. So we're selecting all users from the table where our input is at, and the password is equal to the other input. And so this makes sure that we have an actual username, and then it makes sure we have a password that matches our username and our password from our table. And so what this looks like is over here we have our login here, and if we type something in and we type in a password and we hit login, it's going to say wrong username / password. And so if we come in here and we actually have our actual login made, it'll say we are logged in. And so when we do a SQL injection, basically what we're doing is sending in a request that we decide what it's going to be to the database, to the back end of the website that reaches out to our database server. So this is a pretty simple SQL injection that we're going to be covering here, and we're going to be going into union select statements after this video, which I think are more common than what we're about to go over. And so it's very important to learn the union select SQL injection statements. There are some bug bounty hunters that dedicate all of their time only to SQL injection. So I just made this, I'm shooting this video because I really want you to understand what's going on, and it'll make more sense. Don't worry if it doesn't make sense right now. You may have to come back to this video more than once and go over the union select statements labs on your own, and then come back to them after a day or two and just continue practicing them until you really have them down. And so one of the things that we're looking for when we do a SQL injection is, I'm going to inspect this so you can actually see this happen. We're going to have our console up, ignore my errors because my code is not perfect. When you put in a single quote, it will break this right here, and it will crash our server. So if we go ahead and throw that in, you see our connection is refused, and if you come over here you can see our application has crashed, which means I need to restart it. And now our application's running, and so when you send that, you'll have an internal server error, which is what we essentially just got right here. And so how we get past this is by actually giving it a statement that is true, so that it will give us back the first login in the database. It'll give us back the first username and password. And so we're going to make a true statement right now. And so what we'll do is we'll just throw in, it doesn't really matter, and then our single quote, and then we'll have or 1 equals 1, and then we comment out everything after that. And then our password doesn't matter either, and it says we're logged in. But if we just have this right here, it'll tell us that we're not logged in because this isn't correct. So if we have this in here, what we're saying is this username right? Is this a true username? And the answer is no. You see we have wrong username and password. But 1 equals 1 is always true. And then we comment everything out after this statement with this hash, so our password doesn't work. So you see how this is all in one line of code. This is all getting ran together. It's making this query all together, and what we're doing is essentially commenting out everything after our username, so the password doesn't even matter. So when I say we comment something out, we're commenting out everything after our statement. And so we throw this hash in here, and everything after it's commented out, the password doesn't matter. I think we can get by with no password because I don't have it set up right now that you have to have any characters in here, and it will come back as true. And this is what I'm talking about when we say SQL statement and we're querying a database or a server. Okay, there is one other thing I really want to show us. We're going to go over this again, exactly what I'm showing you right now, in another couple of videos, but I think it'll be helpful to see it. So one other thing is, whenever you give it a database a true statement, it's going to come back without an error or saying it's a logged in. It's going to come back as true. So we just saw the statement that looked like this. We had our username, and then we had or 1 equals 1, and 1 equals 1 is always true, and so it comes back as logged in or it comes back as true. There are other things we can do to get information from a database. See, we want these username and passwords, and we have an ID. So we have 3 columns here that have information in them. Let's say we know the table is users, and we want to know how many columns we have. What we'll do is to pull down something true. If we want to pull down the number of columns because we don't actually know how many there are, and we want to just find out some information from this database, you can actually come in here just like we did before, put in our random username that doesn't really matter, and then this is what I mean when I say a union select statement. So we're going to connect union to our statement here. So we have select all from users where username equals these things, and then we're going to add to it. We want to add a union select, if I can spell. We're going to select null, and this will tell us, is there one column in our table? And we send this, we're going to crash the server. I'll go ahead and send it so you can see we crash the server. I have to come over here, restart the server, and then I'm just going to give you, there's 3 columns. We know there are 3 columns, so we'll throw in null 2 more times, and this will say union select null null null, which is going to pull down how many columns there are. And if we send this, we crashed the server because we didn't comment out the rest of the string that we were querying. So here we go. We'll log in. Now we have no undefined came back, which means we have no errors. So we'd know there are 3 columns. And so this is going to come up in one of our very first SQL injections that we're going to be doing on the Portswigger web application. And there are labs that they have set up for us to practice on, and you feel free to continue practicing in there, but this is something we're going to be doing, and we're going to be going in a lot more detail, and you'll have to pay attention to this comment because it will change between 2 dashes without the semicolon based on the type of database that we're using. So I do apologize if this seems confusing. Hopefully it becomes more clear. It's in the top 10 most common vulnerabilities. I think it's in the top 5 most common vulnerabilities. Looking a little difficult right now because you've never seen it before. But by the end of this module in the course, if it's still unclear, you can go back and try it again and go back through this module, and it will become more clear, and you will memorize how to find these vulnerabilities. So with that, I will see you in the next video. Okay, we are here on portswigger.net. You can go ahead, I actually went ahead and logged in and created a new account. You can come in here and you can come up here, click sign in, and then create a new account. And then once you've done that, come back to the website and you will go to Academy. You can go ahead and click that and it'll load up, and then you'll go to all labs. This will take us to some of the labs we're going to be working through and the SQL injection. If you are having a hard time finding this exact URL right here, I will put a link to it in the description, or you can just type this out in order to get to all the labs. There's a whole bunch of them. We're not going to be going through all of them because some of them get kind of repetitive, and it has been a while since I have done these, at least a year. And so I actually thought what would be good, I'm not going to rehash any of these before we go through them. So you are going to see me make mistakes, and you'll get to see my thought process, and you'll kind of just get to see how I work through these. And so if you want, you can go ahead and open up the first one. And then I like to open it up in a second tab over here, and they'll give you some instructions and kind of tell you what you're looking for here. They'll actually tell you where to find some of the SQL injections so you don't have to spend your time clicking through the whole web application and trying to figure out where things are. And so they kind of point you in the right direction. And so we're looking for a SQL injection with the union attack. And so what this looks like, let's open this back up. So this is what their side of the query looks like. And then we would be typing in, you would close it off. In our case, it's going to be a single quote, union select, and then we're going to be looking for the number of columns and what we can find within this vulnerability. So we come over here and it says find the number of columns returned by the query. And there's a couple of ways to do this. I think I'll show you both. I think they both work in this program, and you can decide what works best for you. So you can come in here, and I actually want to first give you a chance. I'll show you kind of what we're looking for and see if you can find it on your own. So you can come in here, send one of these to your repeater, and see if you can find the SQL injection without any help. And it's okay if you haven't. We really haven't covered this a whole lot, but in the coming videos, we'll be able to do this multiple times over and over. And so you'll get the hang of what we're going through and what we're looking for. Okay, I'm going to send this to the repeater. I'm not actually sure where the SQL injection is even at. I think we'll try right here. Okay, that's what we're looking for. It is going to be right here. And so we're looking for this right here. This is what I was talking about in the last video, the internal server error. If you can produce this error, what you should immediately be thinking is there's going to be a SQL injection here somewhere. It is here somewhere. You just have to figure out how to exploit it. Challenge actually tells us to do is we're looking for the number of columns returned. And so we're trying to figure out how many columns are on the specific table. And so if you think of an Excel spreadsheet, you have rows and then you have columns. And what we're trying to do is figure out how many columns exist on the table. And when you're doing a SQL injection, we're going to be looking for passwords as we go through the Portswigger program, but there are a lot of other things you can look for, and we're going to get to those and exactly how to find them. Even though you're never really going to pull down actual information on a bug bounty program, I wanted to walk through, as someone who doesn't know how to program in SQL, what to do if you come across a capture the flag and you're trying to find specific things such as usernames or flags or passwords. And so we'll get to that in the coming videos, but now we have produced this internal server error, and so we know we are looking for the number of columns using the union attack. So we have our single quote which breaks the query, and then we type in union, and because we are sending this request, we have to send a plus for the space. If you don't have the plus in there and you actually put a space in, it will break what we're trying to send. So union, select, and then you put in here null, which is just nothing, and then you send it, and it comes back with nothing, and then you just hit comma, and then you put in null, and you'd send it, and it still sends us an error. So we put in null again, and we send it. And oh, you know what we forgot to do was you have to close out the rest of the query. So in here we have to put a dash dash, so that comments out everything after our statement here. So, and then we'd come over here and we'd put in null again, and it still says we haven't found the number of columns. And so it hit on the number 3, it came back, okay, so this statement would be true. So when the statement is true, it'll send us back a response. And so we have our response, which means there are 1, 2, 3 columns inside this lab we're working on. And so as we come into the next one, we'll read the instructions and we'll work through it. What I would like for you to do is go ahead and open up the second lab and click access to the lab. And I want you to go in here and do exactly what we did last time and see if you can remember how to find the number of columns in a SQL table. So you can go ahead, you can open that up, see if you can find it, and then if you want to try and figure out how to find the columns containing text, you can Google around and see if you can figure it out. If not, we're going to work through it now, and you will have the opportunity to practice finding columns containing text, as well as continuing to find the number of columns in a table in the future. So this isn't your only chance to try and practice this on your own. Okay, if you were able to pull down the number of columns, then you have figured out or learned what we went through in the last lesson. But if not, we're going to go ahead and work through this one again. So we'll come in here, click on one of these tabs, and we'll have a request sent, a get request, and then we will take it and send it to repeater, see if we can find an internal server error. Might not actually be in this one. Let's see. There it is. It's in this one. So we'll send this to repeater and put in our single quote. There is the error. So this is where our injection is going to be. And so if you weren't able to find it, you can go ahead and from here and see if you can solve the challenge and pull down the number of columns in this lab. So you can go ahead and give that a try now. What we do here, if you remember, is we type in union and our plus, then we select, and then we have our plus, and then we type in our first null value for the column, and then we comment everything else out after the request is sent. And it says we still have an error, and so we try this in. You actually don't have to have these in all caps. It's just kind of common practice for what people usually do, is have things in all caps. I'm not really even sure why, so if you know why, you can go ahead and let me know. So we pulled this down, and we found 1, 2, 3 columns. And so if you made it this far, good job, congratulations. You have learned how to pull down the number of columns, but now we're supposed to pull down which column has text or which ones take text. And so you would put in your single quotes, and then you put in a string and then send it. And that one came back as an error, so we'll try the next column. And it is the second column contains text, and we'll go ahead and try the final column as well. Whoops. Okay, so it would be the center column is the one we would go after to try and pull down information, which is not actually available in this lab, but it is going to be available in the coming labs. So in the next lab, I want you to try and go through this, find the category of where you're going to find your error, and then try and pull down union, select the number of columns, which column contains text, and then we'll work through how to actually pull down the information from that column. All right, I did not notice after I had closed the video that the lab still said it was unsolved. And for those of you that is bothered when a lab goes unsolved or you want to see them all solved, I'm going to go ahead and do that now. So we'll go ahead and I'll show you where to find that. If you want, you can go ahead and try and find it. I actually think this is a good challenge. I think you'll be able to find it. Just go ahead and go into perform the SQL injection, find the one that contains a string, and then look through the response and read through it and see if you can find the answer to solve the challenge. This here solves the challenge for you. So now the challenge is solved, and I will see you in the next lesson. Okay, we are back with the third SQL injection challenge. You can go ahead and click on it and read through the prompt. I'm actually going to give you the challenge to see if you can pull down which column or columns contain characters and will accept a string. And then I'm going to walk you through pulling down data from the table. And then I would suggest practicing, so after we go through it on this lab, to try and go through it again without the video before you move on to the next lesson, so that you can continue practicing things as you see it happening. So we'll go ahead and enter into the lab, and it's going to be pretty much the same. So if you want to go ahead now, I'm going to wait a few seconds and you can pause the video and see if you can complete the challenge and pull down which column or columns contain a string before we go ahead and continue learning how to enumerate the table columns. So by now this should be pretty familiar to you. We're going to come in here, we're going to look for our request that I apparently passed. We'll send this to repeater. We'll make sure that we get our internal server error, and then we'll try our union select attack and send it and see how many columns we pull down. So there's only 2 in this lab. And so what we'll do now is we're going to pull down information from the table. So I'm going to show you how to do that. Then I'm going to give an explanation of the best way, if you don't know any SQL or you don't know how to write any SQL statements, how to find table names if you find this in a capture the flag and you don't want to go through the long process of trying to figure out the table names through writing SQL statements. But before we get there, I'm going to show you, this is what we'll do. We have 2 columns. You'll see, check to see if they'll accept a string, and that one does. I'm gonna go ahead and leave it, and that one does as well. That means there's both these columns have information within them. And let's say there was a 3rd column. If we were to write our SQL statement, we would have to include all 3 columns because the query has to be considered true. You would just leave the null statement in here. And we're going to see some of these in the coming videos. And just to give you an idea that you can go ahead and try and do these, you would do null plus the username. See, this is what you have to do. You'd leave this as an empty column, but in our case we don't have 3 columns, so we're going to just go with the ones that we do have and the ones that will accept a string. And so we're going to pull down usernames, and then we're also going to look for the passwords in the table. So we will look for the password, and this should pull down for us the username and the password from the users table. And see, this looks like a user, this looks like a password, this looks like a user, this looks like a password, and this would be the administrator, this would be his password. So in our response, we have pulled down the usernames and the passwords that are within the table, and this would give us access. If we wanted to, you could log in as these people. If this was a real website, you would have access to their accounts. You can go ahead and turn your proxy off so that the web page loads, and then you will have the usernames here and the passwords, and you can come over to log in and you can give them a try and see if you're able to log in and see if this solves the challenge. There, that one solved the challenge for us. So with that, I want you to go ahead and see if you can figure out the next challenge without any help. See how far you can get and if you can make it through. We're going to skip over this 4th lesson and we're going to jump into the 5th lesson. And you can go ahead and open this up and read through it. This time we're going to be in an Oracle database, and so we're going to be trying to pull down the version that it is running. And so with this tip, we can see there's a built-in table called dual. So they actually give us the table name this time for us to run through. And I think with what you've learned so far in the SQL injection cheat sheet, you should be able to figure out how to solve this challenge. So if you want to go ahead and pause the video now and try, you can go ahead and do that. If not, we're going to walk through the solution together. So we'll open up the page. We'll go ahead and turn our proxy on, and this should all be familiar to you by now. So we're sending that to repeater, we make sure that we get our internal server error, and then we move on just like we have before. So we type in union, select, and then we'll check for a single column. But if you remember, the table name we were told is called dual. And so we can send that, and we still have an error, so let's try for a second column, and we see that there are two columns and the table name of dual. So we'll come in here and make sure they can receive a string, and they can. So what we'll do now is we're looking for, if you remember, the version name. We're trying to pull down the version name inside the response. So we'll come back to burp, and since these can receive string, we type in here banner, and then if you remember from the previous lesson, if we have multiple columns that can receive a string and we're not actually going to use one, we have to leave it with null, so that way that column receives an input. We just don't want anything from it yet at this point. And then for Oracle, the way you pull down a version is $, and then just the word version. And we'll see if that sends it for us. I saw this change in the background to solved. So that gets us our information that we need. And so we should be able to scroll through here and we find it right in here. Okay, in this lesson we're going to go ahead and open up this one, the MySQL and Microsoft. I will just go ahead and tell you they are trying to pull a quick one on us, because instead of using the typical dash right here that we use in Microsoft to close out or to cancel or to comment out everything after your query, you will use a hashtag, and that will stump me. I will come across that and I can sometimes not figure out what's going on, and I can spend a significant amount of time trying to figure it out, and in the end I was using the wrong comment. And so that's one thing to be aware of. And in this lab, we're going to inject an attack. We're going to pull down the type and version of MySQL that's being used. And so this is very, very similar to the last one. And when you go ahead and open up the lab, we are looking to make the database retrieve the string. So I'm actually not entirely sure how to get this to say solved. So we're gonna be figuring this out together for, I guess, the first time. So I'm guessing what we're supposed to do is use our union select attack, pull down the response that we get right here, and try and find the version, which will look something like this, that it's using, and then go back and put it into a string, and it should give us the problem solved up here. So if you would like to go ahead and give this a try on your own, you can go ahead and do that, and I'll give you a few seconds and you can pause the video and then we'll walk through it together. We're going to continue the same way we have been. Turn on the proxy, pick a category, send it to repeater, turn the proxy off, I'm going to lower this so when it comes through as solved we can see it. We'll see if we get our error, and we do. Try it for null, and then don't forget the way we comment out is with the hash or the pound symbol. It has more than one column and it has two columns. So what we will do is we will make sure they can both receive a string, and they do. And so the way we pull down the version in Microsoft MySQL is a little different than the way we did it with the Oracle one. We'll go with the two @ symbols. You type in version, and if you looked through the cheat sheet, you would know this is how you pull down the version for Microsoft. And so what we do is we type in null, because you have to have both columns filled, and then we'll send it. And we came back with a positive response, and so we'll look and see if we can, oh, it solved it for us. It already said solved. I thought we were going to have to find a version number and send it through as a string right here. Okay, at this point things are going to become progressively more difficult in pulling down usernames and passwords, especially once we get to the blind SQL injection, because this is something that we have not seen before. So we're going to be preparing for that by going into this lab right here. You can go ahead and open it up, and we are going to be pulling down the username and passwords, and we're going to log in as the administrator to solve this challenge. I think you can go ahead if you want and practice pulling down how many columns there are and which ones actually receive a string, and you can go ahead and pause and do that if you would like. If not, we're going to go ahead and solve it together. So we'll turn on the interceptor, and we're going to be seeing some new information that we haven't seen before. It's going to seem strange, but I'm going to do my best to explain exactly how the SQL statements work, the default tables, and what we're looking for. So we'll go ahead, send that to repeater, turn that off, send that, make sure we get our error, determine how many columns there are. String, and they do. So at this point things are going to be a little bit different than what we've been doing. We're actually going to be trying to pull down some information from these tables, and so what we do, the first thing we have to do is figure out the table name. So if we have a grid like an Excel sheet, you have your columns that are going up and down, your rows that are going across, and the name of the table. The first thing we have to know is the table name in order to request the columns and then individual cells within the table for us to pull down that contain the usernames and the passwords. So we have our union select, and then we come in and we type in table name, and so this is what we're looking for. If you remember, we're replacing one of the null values with the table name. Then we leave the second one with the null value because we're not going to be pulling anything from it just yet. And then we go from the information schema. And this right here, the information schema dot tables, and this is a default table that you're going to have on every SQL database. So that's how I know this is there. If you were to go into SQL and you were to open it up, you're going to have several default tables, the information schema tables. This is default, it's always going to be there. And so this is how we know what to put in for our injection. Then we send it, and we have an error, which means I'm guessing I have a typo schema. There was my typo. And we pull down and we'll look through our response and see pull down the table names that we have here, and there are a bunch of table names. But if you remember, the one we're looking for, we're trying to log in as the administrator, so we're going to need the users table right here. Users, this is the name of users table. I would suggest copying it and having a text file open, because we're going to need this information. So now we're going to look for the column name. So we can delete this. So the table column is what we're looking for now. So we're going to, actually, I deleted the wrong part of the request. Instead of the table, we're looking for the column name. And we're going to leave this in the information schema dot columns, and this looks right. And now we're going to add to this, because now we're looking for the columns from a very specific table. So now we add a plus, and we'll say where the table name equals, and then our users table that we just pulled down. So we'll type in table name, and then we do equals, and then our double quotes. I think I've actually already got that copied still. And then we paste in our users table. So what we have going on is our union select. So everything that's coming before this doesn't really matter. We're adding a query onto it. We're looking for the column name. We have our second value retrieving null, because we're not looking for anything from it just yet, from the information schema, which is one of the defaults within the SQL database. And we found the table, so now we're looking for columns where the table name, so we're pulling down the table name, equals users. This is going to give us the columns within the table that is named users with some random characters. And so we should be able to send this. So now we should be able to scroll down, and we have column names. So the passwords column and the users column. And so now we should be able to change our query and pull down the passwords and the username. So I'm going to go ahead and copy these. We have the username and the password columns. These are the ones that we are interested in. And now we're going to change our union statement. So now, instead of pulling down a column name, we are going to be looking for the username and the password. So we can delete our null, and we can insert the password column, and here we'll put in the username column in the first slot instead of the column name. And we're looking for the username, the password. From users. Let's see if that works for us, and it does. So we should be able to come through now to solve the challenge. We have the administrator and another user, so we can copy the administrator. We can come back to our lab. Remember, to solve it, we have to log in as the administrator. We can paste in the administrator, and then we can come back to burp and copy our password, and this should solve the challenge for us. Okay, now that was very, I don't want to say complicated, but it was a big jump from where we have been coming and where we've been coming from. And so as we get ready to go into blind SQL injections, it's going to become even more complicated. So you might have to go through this lab several times and make sure that you really understand what's happening. Make sure that everything that's built up to this point is working together. The next lab, I believe, is an Oracle lab. Okay, so you can try and solve this one. It's going to be similar to the one that we just did, only you can use the SQL cheat sheet. We'll go ahead and walk through it again just so we can have one more practice before we get into the blind SQL injections, because these are going to use everything we just learned in this lesson plus quite a bit more we're going to be looking at new aspects within Burp and exactly how to use the intruder tool within the Burp program. So I think it's very important at this point, if I can stress it enough, we're going to have quite a bit of practice going into the blind SQL injection, but it's a lot more difficult than what we just went through if you've never done this before. So go through this again if you have to. Make sure you understand what's happening and what's going on. I want you to try and solve this lab completely on your own. I'm going to give you 2 clues before you start, but other than that, you have already learned everything necessary for solving this challenge. We'll go ahead and open up the lab, and if you remember, when we do go through an Oracle database, you have to use from dual when you're trying to pull down the number of columns within the table. And so since we're looking for we're going to have to log in as the administrator, that should give you a clue to at least how many columns are going to be within the table. And so the other clue I wanted to give you is if you go ahead and open up the SQL injection cheat sheet, when you pull this open, you are going to be using from all tables instead of information schema. So in the last lesson, we used information schema as our default. Well, that's not what we're going to be using this time. This time we're going to use all tables. Everything should be the same as it was last time. The only difference is we're going to be using all tables instead of information schema. And so you can go ahead with that information and try and solve this lab. And if you have gotten stuck, we're going to go ahead and walk through this together now. So the first thing is turn your interceptor on. We're going to go through the normal procedures here. We're send it to repeater, turn the intercept off, and make sure that we have our error appear, which we do. So this is telling us we have a SQL injection. We are going to pull down the number of columns. I know there's at least 2 because we were told that we have to log in as the administrator, which means there's at least a username and passwords column. So we have at least 2 of those. And then we'll go ahead and send this, and it comes back. So there are 2 columns. Both of these are going to have to retrieve a string in order for us to pull down a username and password. So I'll go ahead and check it anyway, but I know it's going to come through, and it does. Now this is where we are going to start practicing what we learned in the previous video. So if you remember, the first thing we have to do is find the table name. So we can go ahead and type in our table name, and this is from. Last time we used information schema, but if you remember, this time we're going to use all tables, and there we go. So this should give us all tables. If you remember last time, there was a bunch of them, but we are looking for the users. I'm guessing this is the one that we need. History. We're going to go ahead and pull down the information. Well, this is we'll grab a couple of them just in case, but I think that's going to be the right one, so we'll keep this one. This is the one we're going to roll with. Now what we'll do is we'll have to come back up here, if you remember, and change. Now that we have the table name, we're going to go ahead and insert this and see if we can find the column name. So we'll change this to column, and we'll leave our null, and it is from. And this time we're going to input in our table into our injection. So we have from all of our tables, and we're looking for, at this point, the columns where it is equal, the table is equal to the table name that we just pulled down. So we have where, and then we'll type in our table name, and then equals our table name. And we'll go ahead, look this over, and then we'll send it. And it came through. Now we have to hope that we have our columns. So we have a password column pulled down, and we have the username. Okay, now we have to change our injection one more time. So this time we'll be getting rid of our null value, and we're going to be putting in first our username, and then we're also looking for the passwords, which will come from our second column, and this is going to come from our table name, which I actually think we delete this. We'll delete that, and we'll delete this. And we have an error, comma, and we have pulled it down. So this should have our usernames and our passwords in it, just like the last one that we walked through. Here's the administrator and the password. And so if you remember, we have to log in to actually receive the solved lab up here. So we'll go ahead, paste that, and we'll copy and paste this and send it, and we have solved the challenge, and we are ready to start the blind SQL injection. We are going to go ahead and open up this lab. While it's loading, I thought I would just tell you this is going to be, the next couple of labs are going to be a little more difficult, and I think that you should practice them just to get this ingrained into your mind, what exactly is happening, because we're going to be adding quite a few new steps, but they actually let us skip what we have been practicing, because in the instructions they give us that we are going to be working with a table called users and two columns, usernames, or the username and passwords. So we don't have to go find the table and we don't have to find the columns, but we do have to still log in as the administrator to complete this lab. So you can go ahead and open up this lab, start this lab exactly how we normally would, by opening up one of these tabs, forwarding it, and then sending our request to the repeater, because what you're looking for is a request with this tracking ID. You need that tracking ID because that's where the SQL injection is going to be. So we'll send this, and you can send it a few times, and what I'm looking for is this content length. I want to make sure that it does not change, and sometimes you will send this on some web applications and it will change every time, no matter what you do, the exact same GET request. But for us, in our case, it stays the same, which makes this lab much easier to solve. And when you have this tracking ID, you can also check it as well for the SQL injection. And so you send it and you can see the content length has changed. So it's 4906, and you send it and now it has changed. This tells us there is a possibility of a SQL injection. So what we're looking for is what has actually changed in our response. Here, what I like to do when I come across a different response is to copy this and take it to a text editor. I think it's easier to read through and to look at, and I also can search, which we are going to do right here. So when it comes back without any modifications, we have the, let's send this again, we have the welcome back is on the page. When we put in our single quote to try and provoke an error, the welcome back is gone. So you can see we have 0 matches right here. And so with our 0 matches, we want to send a true statement to make sure that we can really add on to this query. So we go or 1 equals 1 and then comment this out. That comes back as true. So we know that we can give some kind of request and see what comes back true, what is actually true and is on the database will come back with this welcome back, which is what we're going to have to pay attention to. And so because we've already been told what the table name is and the column names, we can go ahead and start to look for information from this table. So we'll type in our usual union select, and this is where it changes, because we're going to now add a character into our query. So we're going union select from, and then we're going to go to our users table, where the username is equal to, and then remember we were told we need to log in as administrator, so the username we're looking for, and we are going to send this and see if it comes back as true, and it does. So we have this, and now what we can do is we can actually add on to it, and we can look for the length of the password. And so you can come in here and you can look to see how long the password is, and you can pull down the length of the password, and you can come in here and you can go plus and plus length, and then we add in the password, and then you would add is it greater than, and then you can start right here and you can start sending to see is it greater than 1, is it greater than 2, is it greater than 3, and you can send this to the burp repeater and just continue seeing is it greater than and looking through this. What I am going to do is I'm actually going to skip this process for the sake of time, because we're going to have to go into a burp intruder and start looking for the actual password. And so what we're going to do is we're going to send this query over to the intruder and see what we can pull back. So I'm going to go ahead and take this query here, and what we're going to do is we're going to take this and we're going to add into it the characters that we're looking for. And so you would add in that you're looking for the first character and only one character inside the query, and then you're going to start with the character A. Now this, at this point, I'm sure if this is the first time you've ever seen anything like this, it looks very strange, and it is going to feel really strange doing things like this. It's new and it's kind of confusing, so we'll send this not to repeater, to intruder. And so we have this new string that we're sending. So we have our normal union select, and then we have a string from users where the username equals administrator. So we're looking on the table name users under the column username for the administrator's password, and we are looking for the actual password at this point. And this, actually, I just noticed, we're not looking for the length of the password, we're going to be looking for the substring. So we'll come over to intruder, we'll look at our positions because we've already sent this over here. We'll clear where it wants us to start querying, and we are looking for the substring in the password. And so we will go ahead and set this up. What we do at this point is, as we set up our payload, you will add the whatever those symbols are to tell it this is where we want to shoot through, or we're going to use the cluster bomb. So this is where we're going to be going through and sorting to make sure we have the right characters, and then we'll add right here, because if you remember, this selects the first character, and then it's going to go through the first character for all of the characters that we give it, but then we want it to go through the second character as well, and then the third and the fourth and the fifth, until we reach the end and we have the password. I don't have the professional version of burp on this system, and so this is actually going to go really slow, and once it starts, I'm going to go ahead and pause the video so you don't have to wait for it to pull down the password, because it will actually take a while without the professional version of burp. And so what we're going to do now is we're going to set up our payloads, And so if you remember, payload 1 is going to go to this position, and payload 2 is going to go to this position. So the first payload, we're going through numbers. So we will find numbers, and we're going to go from 1, and this is when I guess it would have been helpful. I'm just going to go really far. This is when it would have been helpful to see how many characters were in the password, so you would have known how far you needed to go. And then we're going to go by a step of 1, so it's going to go up 1 character once it goes through all 30 characters, and then position 2, we are going to be going through the alphabet. See if it has the alphabets in here for us. I believe it does. Manually add these in, it would be a lot easier to go through these without having to do this, but I will edit this out. Alright, I believe we have all of the characters added in. What we can do is we can go ahead and start the attack, and we can say okay. And now it is going to go through and start working through all of those characters. So position 1 and A, is position 2 and A, is position 3 and A, and it's going to go through and check every character for each position until one returns true. Okay, I have gone ahead and cut the video in the middle of where we were after starting the attack, and you can see that it's been running and we've pulled down some of the characters that we've needed. One of the things that might be helpful, if you copied exactly what I had typed in into the payload or into the query right here, I actually had a error, and I had to go through and change that and fix it. And then that ran for a little while, and then also my computer fell asleep while running this, and it closed out my query, and so I had to restart it. And so this has been running for what feels like forever. And so I'm going to go ahead and we're going to stop it here, and I'm going to show you a little more manual way. And it's also a lot faster because if you can see, it's sending one query each time to the server, and it's very slow, anywhere from 10 to 15 seconds. And it's because we've sent so many. And this is one of the things Burp does in order to get you to buy Burp Professional, so that it'll send them really fast. So they've throttled this down. But I'm going to show you a way that you can kind of get around this and send your queries a lot faster. Before we start that, I kind of wanted to show you our positions just in case it wasn't clear. Remember, in our query, we are selecting from the users, the table users, where the username is just the column, and we're looking for the name of administrator inside the password column. And so we're sending, this is the first character in the query. So this would be position number 1, and then it'll change and it'll go position number 2, and then position number 3, and it will send A all the way through however many we set those positions, 1, 2, 3, 4, 5, 6, to see if an A comes back as true in any of those cases. And if it comes back true, we'll see something like this. You can see the length has changed and the welcome back is present in the response. And then once it goes to all of position 1 for all of the alphabet, it will go to B, and then it will start over and it'll continue and it'll go through like that. This is a very automated way. We don't have to really do anything. We just set it up and let it run. But if you don't have Burp Professional, this can take a very long time. And one thing before we go ahead and I show you how to organize this to find the password is that in order to get this welcome back to show up, what you do is you can check in your response and you can have your welcome down here. And if you can see these, it matches. The welcome has come back, which means it's true, and we have a match. For these down here, it is not true and there is no match. And so we can sort out the true characters that exist and in which position they exist. So there's a G in position 2. There's a G in position 15, we have a K in position 8, and so on. And so we can know this is where there's characters and this is how it's true. But in order to get this welcome up here, you have to go into your options. You will come down, so it'll start you up here. You'll scroll down to grep match, you will clear what's in here and you will add welcome. You'll get a little pop-up, you'll just click OK, and then it will bring you back to your results and it will look like this. And what you do is you just click this and you click it again until we have the arrow facing down, and it will have all of the characters there for you as it runs. Now the way I like to sort out the password is to have a text file open, which is right here. We have our text file. We'll delete this and we'll delete this and we'll paste this in. So what we have here, we'll also delete these because these are just our query numbers on how many GET requests were sent to the server. And I think the less numbers we have, the easier this will be to understand. So this, if you remember, let's open this back up and have our text file. This is the position from payload number 1, and this is the character that has come back in payload number 2. So what you would do, so let's say this is what we've brought back, and the query is finished, even though we know it's still running and it's going to take 5 more hours for it to finish running. So what we'd do is we'd have our password equals, and you'd come here and you'd go, okay, position number 1 is I, and then we'd look for 2. 2 is O. Position number 3 is a K, and then position number 4 is an I, and position number 5 L, and position 6 is a G, and then you'd go along and you would just continue doing this all the way through. So we go 6, and then we go 7, and then 8 is a C, 9 is N, and by the time you've gone through all of this, this is your password. And so we were told that the username is administrator and the password is what we're pulling down right here. And we'd come over here, we'd go to our lab, and this is where we would come in, we'd click login, you would use administrator, and then this password that we have just pulled down. So if you want to let your intruder run for ever, because it is really slow, especially once you get past about position, after you get past request number 30 to 35, it really slows down. So I'm going to go ahead and close this out. Okay, we are going to look at the blind SQL injection with time delays. So what you'll do is, if you find what you believe to be a SQL injection, you will inject a time delay, and they're pretty simple. But I also want to look at the cheat sheet because they're going to be different, and we're only going to be looking at this one right here. The blind SQL injection with time delays is really simple to the one with conditional responses, which we just looked at. The only difference is you would be running a case then statement, which if you're a programmer, it's like if then, and you're going to be saying if this is true, then sleep, and rather than if this is true. So with the cheat sheet, these are all going to be different. So you'll have to run this to get your program to sleep. For your delay with Microsoft, it's going to be like your syntax is going to look like this. For PostgreSQL is going to look like this, and MySQL is going to look like this. And so each one is going to be a little different, and you might have to just try each one and see what comes back for you. Okay, so this is, we're going to have to solve the lab, we need it to sleep for 10 seconds, which is kind of a long wait, but 10 seconds feels like forever when you're waiting for a response to a GET request. So we will go ahead and turn the interceptor on. Open this up. I think I clicked in the wrong spot. Oh, there's a tracking ID. We have one right there. And this will look, let's see if it says it's blind, so it's not going to have anything for us. I'm actually going to go ahead and go to an item so that I know I'm in the right spot and you guys don't have to watch me fumble around like you are right now. So we'll go ahead, send that to repeater, and the SQL injection that we're looking for with the time delay is the PostgreSQL right here. So what we'll do is we'll use this syntax right here, the PG sleep 10, and we're going to have to concatenate it
to our query. So it's just 2 types, which is just above your enter key or your return key if you're on a Mac. And then you just type in the syntax exactly like you just saw. And then we don't forget to comment out the rest. And that should take 10 seconds for our response to come back. And once that response comes back, we should have a solved up here. And so the time delays are really simple. They're really easy to run, and this is how you do it. I'm not sure why that didn't come back as solved. Maybe we have to go ahead and forward this. There it is. There's the solved. So they're really simple to run. They're really easy proof of concept. You can change this to 5 seconds if you're impatient like I am, and wait just 5 seconds instead of 10, but you have to do 10 here to solve the lab.
Okay, we are ready to start directory traversal. We have talked about this just a little bit earlier when we talked about navigating through files, and we talked about going through files such as this. So we would cd into the desktop and it changes us. We change into that directory. And so we're able to go between directories and go into different files. And the way we go backward, if you remember, if I wanted to go back to my home, I would just go back 1 directory and that takes me back. A good way to practice this, and maybe you've done this earlier, is to open up your home folder and just up here in your little search bar, you can practice going backwards, or you can practice going forwards. And so we would just be going forwards like this, and then we can go forward again and we can go into our desktop. And then if we wanted to go back, we would just do 2 dots and a slash. And so in directory traversal, we will be going through files only in our browser. So we would be going backward through here. And we talked about this a little bit in the previous lessons. And so we're going to go ahead and open up our Portswigger in our labs, and you can scroll down until you find the directory traversal. And then we're going to walk through a few of these manually, and then I'm going to show you a tool that does this for you. And I will pull up a directory traversal that is found on HackerOne, just so you can look at it and you can see just that these are not something that's lost out there and somebody's found them all. Actually, recently, I would say within the last 2 years, someone found a bunch of directory traversals. They were able to pull down files that they should have never had access to on the Department of Defense. And so if you would think of any organization that's going to have good security, you would think it would be the DoD. And these were found recently within the last 2 years, directory traversals on the DoD. And so it's out there and they happen. I've actually found a few of them, and we'll go through them manually, and then I'll show you a easy way to fuzz through with a tool that will actually pull down and tell you where a website is or a web application is vulnerable, and exactly which exploit they used to prove it's vulnerable. So we'll do that after we go through some of these manually. Okay, we are ready to go ahead and open up our first lab. And you're going to be able to see just how easy these are to find manually, as I think they're really simple, and anyone can go and try these with really knowing very little about how the web application or locating files works in general. You can pretty much find these straight off your very first day. So we'll go ahead and access the lab and turn this on, turn on our lab. And while that's opening, there's a few different ways to look for these. Probably the most common is going to be up here in your address bar. You'll come up here and this is where you'll search for them. And I'll just go ahead and show you. What you would do is you'd pull this open and you'd hit your slash and you'd go // and then you would hit enter and see if it can take you back any files. But it is not going to work for us. in this bar, we're actually going to have to use burp for this. And so we'll go ahead and turn it on, turn our intercept on, and we'll view details. And so what I'm going to go ahead and do is send a few of these requests to repeater, because I'm not actually sure where exactly we're going to find the traversal. So we'll go ahead and send that to repeater as well. And I think that's it. So we'll go ahead and open this. And so if you remember how to go backward in our files, we'll actually start with the first one we sent. We'll go ahead and delete this. And so we're looking for the product ID, and you would go .. / and then what we're looking for, if you remember in the lab description, is the Etsy password. And so we just type in etc/password, and then you can send it. And it says we get a bad request. And so we'll go a couple more and see what happens. Okay, so we're getting a bad request. What we'll do is we'll go over to our other get request, and we'll go ahead and do the same thing. I like to go ahead and start out just like this, and then add to the path traversal as we go. And so I just go just like this and see how far we have to go before we can actually find the files. In this case, before we solve the lab. Okay, so there it solved it. So it goes back to the root folder, and then it goes forward into this file, and then it'll go forward into the password file, and it pulls down for us information that we should not be able to have access to. And so for us, this should solve the lab for us. So each one of these just goes back one file, and it goes back until it hits the root folder, and then it'll go forward into this directory, into this file. And that will give us information that we should not otherwise have access to. Okay, we are ready to go ahead and solve our second lab on path traversal. So you can go ahead, I think with what you have learned so far in the very first lab, you should be able to solve the second lab on the directory traversal. So if you want to go ahead and give it a try, you can open up the lab, which I've already done. And you will be looking for the same file we were looking for last time, the Etsy password file, and that will solve the lab for you. And so you can go ahead and pause the video now and see if you can solve this challenge. Okay, how did that go? Hopefully you were able to solve it without any trouble. If not, we're going to go ahead and walk through it now. We'll go ahead and turn on our interceptor, and we will click one of the view details just to make sure we can pull down the same get request we had last time, which was not the product ID. It was the image file name. So we'll go ahead and send that to repeater. And while we're over here, we're going to start out just the same way we did last time. We're going to come in here and start with our Etsy password. And then as necessary, if we need to, we'll go ahead and add in the .. slashes. But we always start at the beginning and go forward go backward if necessary. So we'll go ahead and send this, and it came back on the first try. So hopefully you were able to solve that challenge, because they're going to get a little more challenging to do manually, but not all that difficult for us. Okay, we are ready for the third challenge that we're going to be looking at for the path traversal. And this one, we're actually told what's happened. So go ahead and open up this lab, and we'll see our instructions here. And we're told that the sequence is stripped away non-recursively. And so what we will have to do is modify the attack just a little bit, and pretty regularly, especially with cross-site scripting, you will see developers that know of a way or maybe a few ways that an attack can be performed. And so they'll just go ahead and strip out just specific elements or sequences within a within an attack or a payload so that they won't go through, but there's almost always another way to pull this off. And so actually in this lesson and the next one, we're going to be able to observe just how you change payloads. And really in bug bounty hunting, what you're going to be doing is a lot of trial and error until something works. And so we'll go ahead, open up this lab, and once you're in here, you will click View Details after you've turned on your intercept. We'll go ahead and turn that on. And my son would think this is the coolest toy ever. And so we'll go ahead and view the details. We'll get our GET request that we need right here. We'll send it to repeater. We'll turn the intercept off. And once we're in here, we'll go ahead and we can start out with the Etsy password. And then we'll send this, and it comes back with a bad request. And so you can go ahead and try going back, and it comes back with a bad request. And I actually know what is going on because we're told that the traversal sequence is stripped away. So what we'll have to do is try something different. And so what you can actually do is go 4 dots with 2 slashes. And then this is going to be a different process in pulling down the Etsy password file. So we'll send this. And then we will 1, 2, 3, 4 continue going. And we are able to find the file we need. Now, when it comes to remembering all of these different ways that you can try and find a directory traversal, it is not necessary to try and remember these. I'm going to show you a tool that actually does all of this for you with hundreds and hundreds of different ways to pull down an Etsy password file. And so I'm just showing you manually how this works so that you know what's going on and you know how to find these, just in case you're not allowed to run a scanning tool or anything like that on a specific web application. But you do not need to try and remember all of these different ways to pull down the Etsy password file, because you will have sources available that can do it for you or remind you exactly how to pull off these attacks. Okay, we are going to be working through our final path traversal before we look at how to do this with the automated tool. And so you can go ahead and open up this lab, and in here we can read our instructions and exactly how to pull this off. And so we're told that this has URL decode in it. And so this is actually very similar to a exploit that was pulled off. And I came across this not too long ago when I was looking through path traversals and how they were pulled off on the Hacktivity. And so we have, this was done June 9th, 2018. So quite a while ago, a couple years, but this is going to be pretty much the exact same exploit we're going to be doing in this lab. So just to show you that these labs aren't just theoretical, but they actually do help you perform these exploits. And so you can see here, this is the URL encoding. And so a simple way to look at URL encoding is you can come over here to the decoder, you can type in some gibberish, and then you can encode it as URL, and you will see the URL encoding pull down here. And so what we are going to be doing is doing something very similar to what this guy has done here. And you can actually see he actually pastes, it pulls down the file that he should not have access to. So what we are going to do is come in here, you open up the lab, click access the lab, same as we've been doing in the last few lessons. We'll open up Burp, turn on the intercept, and we will view details of one of the files. We will look for the GET request with the image file name, send it to repeater. And now what we're going to do is very similar to what we just saw. So we'll start out just like normal. You can go ahead and send this, and then we are going to type in the URL encoded version because it's going to decode it for us, which is 252F, and that should pull it down for us. And we'll go ahead and delete that because it's encoded in there. And so we can send that. I'm going to do, rather than type this, is I'm going to go ahead and copy it and then paste it and then send it and then paste it and then send. And there we found the file. And so you can actually really easily see how this is very practical. Here we're practicing it. Here someone actually pulled it off on a live website. And so if we come in here and we turn our proxy off, we should solve the lab. And so in the next lesson, you are going to be required to open up JuiceShop, because this is the URL we're going to be using to pull off the attack on our automated tool. So you can go ahead and open up JuiceShop and get it running. Okay, we are going to be looking at the automated way to find directory traversal exploits. And so you can go ahead and open up a terminal and have JuiceShop open and running. And just to make sure you have the tool installed, you can come down to your terminal and you can type in sudo apt-get install. It should look exactly like this. And then you will hit enter. It will require your password, and you can go ahead and type that in, and it will run, and it might ask you, are you sure you want to install? And you can press Y and then hit enter or return if you're on a Mac, and it will install. And so the way to run this tool is very, very simple. You would just type in .pwn, and then we will give it the parameters that we want it to follow. So we'll just type in .pwn, and then we will go -m, and this is, I actually already ran it just to make sure it would run on our local server. And so this is what you will type in. You will type in .pwn, and then you'll flag m http, and then you'll flag h, and it's our local host. And so I actually just came up here and copied and pasted the page I was on, and when you hit run, it will run for us. Oh, it did not run for us because we have to run it as sudo, as our super user. And now it is running, and it'll ask us, press enter to start the testing, and then we'll go ahead and hit enter. And now you can see, look, it is running all of those for us with the ///, and then it encodes it, and it just runs through, and it tells us even where it's vulnerable. Now this web application is vulnerable, I think it's vulnerable to all of them. They did not do a good job when building the web application for making it secure to this attack. And it will run, and there are hundreds of different ways to send. There's the one we just saw with the %252F, and it runs it for you, and it'll tell you, for us, it would have been right here. We would have had 3 paths to go back before it goes forward into the Etsy password. And so it would have found it right here. It would have flagged it as vulnerable. So now you can see just how easy it is to run this with this tool. And you can go ahead and hit Command C to close out of it so that it'll stop running. And it might have actually went ahead and solved a challenge for you. If it didn't, you can go ahead and type in // really any of these, because it says it's vulnerable to them, and then type in etc/password, and it should pull down. I think I already solved the challenge. It should pull down that we have accessed a file that you should not have had access to, and so that will solve that challenge for you. It's pretty simple. Running this tool is really easy, and it takes a lot of the manual testing that we just did out of account for us, and it will run hundreds of different ways to find a path traversal.
Okay, we're going to start by looking at the XML injection at this point, and we're going to start a really easy XML injection. This is one that you're going to see that's probably the most common, and then from here we're going to look at some more uncommon XML injection methods, but they're going to be a lot more severe. And so this first one is really simple. You can go ahead and open up this lab on Portswigger right here, And I want to walk you through, we'll go ahead and click Access Lab. I want to walk you through what is happening. So when we look at this XML injection, I want to focus just on these two lines. When you see this XXE right here, we can change this to be anything we want, and we see it down here. It is the same thing. This is the XXE being called and telling the XML file that we want it to do something right here. So we're going to tell the system to open up the etc passwd file. And so I will show you what this looks like. When you come up here and you click View Detail, we will need to turn on burp and forward this to repeater. And we can now turn this off. And we're going to need this right here. So we can copy and we'll paste it in right here at the top. And now we're going to delete this first part right here, and we're going to change, we can leave our, I guess we'll leave our doc type as foo, and we're going to change this right here to etc, and this right here to passwd. And then down here where it says the product ID, what we're going to do is we want to call this right here to tell the system we want it to do something. So if you remember what this looked like over here, we have the and XXE with the colon, we need burp, and where that product ID was, we can paste this in. And now we'll send it and see if we have any errors, and we do not. And it provides for us the etc passwd file. This is a pretty big vulnerability. This is something you shouldn't be able to look at. This is something you shouldn't be able to look at, and it will give us users that are on the system. So from here, we're going to move on to TryHackMe, and we have a Juice Shop, which is a really great place to practice a lot of web application vulnerabilities. And we will hop over here and pop open a machine, and I'll show you a file upload XML injection. We'll come over to OWASP Juice Shop. You will need to click on login and create an account. So I'm going to create an account, and then we'll be back at the home page and I'll show you where to start from there. Okay, so we are all logged in and we are now at the front page. We'll come up here to the 3 lines. We're going to say we want to file a complaint, and we'll just say a bunch of gibberish. And now we're going to need to upload a file. So we will create our XML file by coming over here and gedit, and this is what we'll just name our file so that way we know what it is. I'm going to make this on my desktop so that it's easy to find. And now we need our code to inject with. So we'll copy this. We can move it over here to our file, and then we'll just change this to etc passwd and save it, close it, and come back over here to Juice Shop and click browse. We go to our desktop. We want all files, XXE, open. We need burp to intercept this, so we'll come back to our proxy, intercept, and submit. Send this to repeater. I actually don't remember which one this is, so we're going to send a couple of them. We'll send this, and we'll just turn repeater off and hope we got it. So it says we've solved several of the challenges. We'll come to repeater. We'll go back here to the first one. We'll send it, and right here is the passwd file. It doesn't come back in quite as nice a format as our original one that we had done on Portswigger here, but we have the XML injection worked, and we have the passwd file, and here's the root user. So this is a file upload XML injection, and now we're going to cover a XML injection that's going to lead us to remote code execution. And you can actually see right here, they tell us remote code execution if we are lucky,
and the PHP accept module is loaded, we can get remote code execution. And we're going to go ahead and try this, but this is on HackTheBox. And if you don't have a subscription to HackTheBox, that's okay. This would be something I have never seen outside of HackTheBox, but it's something to be aware of. So we'll go ahead and I'll open up HackTheBox, launch the box, and get all set up. And then I'll walk you through an XML injection with HackTheBox. All right, I have popped open here for us the HackTheBox machine. This is the landing page, and if you run a Dirtbuster or FUF, you will find this db.php, and then we have the portal.php, and we click this, and we are brought to this page. Now, if we go to test it, grab our interceptor, and we just put something in here, and we send it. We'll send this to repeater, turn this off, send, and we have this value right here, data, and this is what we get back. We have this data parameter right here. We can copy it, come to our decoder, and we can decode as URL, decode as base64, and we see we have this XML. We get an XML return that has been base64 encoded and then URL encoded. And so what we can do with this is try and add to it or adjust it and see if we can pull off an XXE attack by just reversing this. We can add in our own payload, and then we can encode it as base64, then URL encode it, and put it back into the repeater tab right here. So what we'll do is come over and we'll just try to pull down the, Etsy passwd file first. Okay, one other way to look at this that is a lot easier, rather than just coming into the decoder and decoding this as URL and then base64 to get to the XML file, is we can go to our repeater, and remember we have this data here. We can come over to our inspector, and then we can click this little arrow right here, and it will automatically decode this for us, and we will land right here, and we can actually do our changes right here, apply changes, and resend this and get our our response brought back to us. So what we will do is come over, we'll go to OWASP, and we will grab the XML right here, the XXE. We'll open this up to grab our payload. This is not the one we were in earlier, but that is okay. So what we will grab is the doc type and the file system, and we'll stop right here. We can copy this. We'll put this on a new line right here. We'll actually try to see if this will let us put this all on one line so that it looks better for us. Now that we have this on, well, not one line, but it's a little better. Here we go. There we go. Now it's on one line. So what we're going to do is similar to what we've been doing before, is we can just leave this however we want. We're actually going to delete this. We don't really need that, and it looks a little better for us. This goes on a different line. Guess we'll leave it. Okay, so here we go. What we can do at this point is type in Etsy/passwd, and then down here we need to call the XXE. So we can go our and symbol, XXE, and our semicolon, and apply changes. And if we send this response, you can see right here we have the passwd file brought down for us. And so one of the things we always should look at, especially when we are on a HackTheBox, some kind of CTF, or even a pen test or a bug bounty program, you really wouldn't do this, but you would look for the users, because you may be able to attack some of them. So we have the development user, here's the user ID, we have root obviously up here, and what you can do is just look for the ones that have bin bash, and those are the ones that will have a shell available on them. So we have development and root, and a quick look, I'm not really seeing any others. And now what we can do is try to pull down that db.php file, but in order to do that, you will have to use a PHP wrapper, and those are something I would suggest learning because you will see them every now and then whenever you see a PHP system running. A lot of times you can think PHP wrapper and see if you can pull down information that you should not be able to. And there's a lot of different places you can use those PHP wrappers, but one of those places is going to be right here. So instead of pulling down a file, what we're going to do is we're going to type in here PHP, and we can delete all of this and type in filter/convert.base64-encode/resource equals, and instead of the etc passwd file, what we're going to be looking for is the db.php, and you can find this typically if you're familiar with doing CTFs or any kind of pen testing. You will know that you can find the files you can find the files for a web application inside of var/www/html/db.php, and this is pretty standard for where you're going to find files on a Linux system. And we can apply changes. We can copy this. We can go to the decoder, paste this in, and as we decode it with base64, it tells us that we have this in our response. So this would be what was brought back with our PHP filter, and we have a username right here. We have the database name, we have a password right here, and we should be able to SSH in as the development user using this password right here, because we know it's really common for people to reuse their passwords, and this will actually lead to remote code execution. So if we come over here and we say SSH, and then we say, make sure we had that user right. I think it was development at 10, 10, 11, 100. We might have to grab that user again. We'll say yes, and come over to the decoder, grab the password, and paste that in, and it worked. So this is how you can get remote code execution on the box on a server using XXE. And so with that, this one was really complex, but XML injection is something you should look into and try to learn. I would suggest going back to Portswigger and maybe practicing a few of their XXE challenges as well as Juice Shop, and just play around with it until you feel like you are comfortable and you understand what is going on. So there are 3 different ways that you can use XXE in the cybersecurity testing world. Okay, one of the most common vulnerabilities is going to be cross-site scripting, or it's also known as XSS. And this vulnerability is common, but it's also going to be pretty hard to exploit without knowing some form of HTML and JavaScript. So there are basic payloads that you can go in and you can just test a bunch of them. And I'm going to show you a list that I found. It's got over 6,500 different ways to try and exploit this, but most of the time you're going to have to inspect the page and modify the content. But we'll get to that in just a little bit. I'm going to show you just a couple of cross-site scripting examples here, and then I kind of want to show you the code of what's going on. I think you'll be able to understand it even if you know zero programming. So with that, we'll go ahead and I'll show you an example of what cross-site scripting is, and then I'll explain why it's so dangerous. And so this is going to be the most basic, simple form of cross-site scripting. And so all we want to do is have an alert pop up. And if you can pop up an alert on a bug bounty program, you will be able to submit that for a vulnerability. And there you'll see them a lot of places. A lot of people like to look for them. I don't really look for them all that often because I think most people look for these, and if it's not stored cross-site scripting, then you're not really going to get paid for the amount of time that you put in. You'll get paid, but just not enough for the amount of time it's going to take to find them. So we're going to do this with an image tag. So we'll go image source equals, and then we leave it blank. And when this is blank, it's going to make an error on the page. And so on error, we want to alert, which is going to give us the ability to pull off the cross-site scripting. And we're just going to alert 1, and then we will close the tag. And I have made a mistake somewhere. Let's go ahead and delete this equal sign. There it is. So we have the alert pop up and it says localhost 1. Now what you can do with the cross-site scripting and why it's so dangerous is not because you can just pop things up on somebody's screen, but what you're able to do is you could make this look really fancy, and you could say log into a Wi-Fi or log into this page, or you were accidentally logged out, and people can type in their username and their password, and then all of a sudden you have their credentials. You can put alert document.cookie right here, and then all of a sudden you can steal their session. And so there's quite a few different ways that you can use this to get malicious with it. And so that's why it's so dangerous, but it's also really common. It's going to be in the top 10 vulnerabilities that you're going to find on pretty much any list. And so right here is a different version. So right here is just plain as can be. You can type whatever you want and nothing's going to get blacklisted. So right here, I have made a little, it's really short. It only has the image tag, but you can type your script. The image has been blacklisted. So what I mean by that is if you watch what happens, I finish typing image and it automatically deletes it. This will happen on programs that you're going to test. That they'll have characters that are blacklisted. I come across it regularly. I have come across blacklisted characters when I was trying to do a SQL injection. So you'll come across blacklisted characters. What you'll do is you can go out and you can find encoders and you can encode your payloads in order to fit your specific needs. And in this case, it's pretty simple. All you have to do is go I and make a capital M and a G, and it doesn't get deleted. Or you could go capital I, M, G. And this is a way that you'll find, especially on Capture the Flags, to bypass blacklisted characters or words. Is you just change it a little bit, or you can encode it and you can bypass the filter. And so we could do the exact same thing that we had done before. So we'll go on error equal alert, and then we'll just do alert 1, and then we'll close it off. And there's the alert. So all we really had to do was just change the image tag, because the image had been blacklisted, but we were allowed to pull up a different version of the image tag. And so what this looks like, here we have banned characters. So you can have banned characters such as these. People will ban these characters so that you can't inject your code into it. But I will show you. So in this case, I actually ban this character, the backslash. So no matter how many times I push it, it's not going to come in. But you can still ban this. You will find the backslash ban, because if you can't close a tag, then it's going to be really hard to pull off a cross-site scripting. Not impossible, but you can still do it. So what this looks like is I am just replacing the image with an empty string. And over here we have the banned characters. You can see right here, you're not allowed to use those, and I replace them with an empty string. And so this is what a blacklist would look like. You just have a bunch of characters listed that are blacklisted, and you're not allowed to type them in. So when you have a banned backslash, which you're probably only going to see in Capture the Flags, something like this. But what you can do is you can actually make a button tag like this. If I can get that right, there we go. And then you can just type something in here. And then what you can do is you can type in on click equal, and then you do the same thing. You'd put your alert, and we'll put our 1, and we don't have to have a closing tag. We don't have to close that. So we click it, and there's the alert. And you will see this in one of our practice, when we practice the cross-site scriptings. So those are just a few ways you can pull off the cross-site scripting. I want to show you a page that has a ton of cross-site scripting payloads, and here it is. You can actually just Google cross-site scripting payloads, which we'll go ahead and I'll just do it right now and walk you through it. We'll just type in payloads and just click the first one, and here's going to be a list, so you can get an idea of how many are out there and different ways you can do a cross-site scripting. And so this is why I'm telling you there's a lot of different ways to do these. We'll actually see one similar to this in just a few lessons, because we're going to have to close off a tag, and then we're going to have a character blocked, and then we'll actually be able to insert the payload. So there's a ton of different ways to pull these off. It's going to require some knowledge of HTML and JavaScript, or you can, if you're on a Capture the Flag, you can just go to burp intruder, and you can just send this entire list until you are able to receive a solved challenge. But with that, this is a basic introduction into cross-site scripting, and we'll get a little more hands-on, and I'll have you guys start practicing writing your own payloads in the coming lessons. Okay, for this challenge, I want you to come to the HackerOne or the Hacker 101 CTF. This is HackerOne's practice site for us to practice what we've learned. You can come in here to the easy with 2 flags and click go. If you would like the challenge, we have already saw the XSS in this challenge. I showed it to you in the last lesson. So if you want to go ahead and look for it on your own, you can go ahead and do that. I think you have the knowledge to solve this challenge all on your own without any help, but I will do a walkthrough here in just a second. So if you would like the challenge, you can go ahead and see if you can find the cross-site scripting, and you can do that now. Okay, once we're in here, you can go through, and one of the first things, if you remember from the recon lesson, is to click through and just open up everything in the page and just see what you can find and what you can do. I actually just thought of another way to try and solve this challenge that I might try and see if it works. And then you can come back and you can go back to the home page, you can create a new page, and you can just click through and see what you can find. But in the markdown, they actually give us a clue as to how to solve this challenge. You have this random button here, it doesn't do anything, but if you edit this page, we have the tag for a button. So if you were unable to find this, you can go ahead and try and solve the challenge now. Because if you remember, if we have a button, we can come in here and we can go on click and then we can put in our alert, and then we can put in 1. And so we have our on click here, and it's closed off, and we should be able to save this. And on our click, we are given the alert. I just thought of, I bet we could copy this. There's another way you could have solved this. If you didn't see this button here, and you didn't have this clue, but you came into the testing and edited, and you saw this, you might have thought to go ahead and just insert your own button, and you could have pulled off the same thing just on a different page. And we'll go ahead and change this to just click, just so you can see it's a different button on a different page, and we could have done the same thing. So that is another way that we're able to pull this off, and we're going to see a couple of more examples. And the reason for this is the cross-site scripting is a rabbit hole that you can go down indefinitely. There are thousands and thousands of different ways to pull this off, and so I just want to show you the basic introduction into cross-site scripting, because without knowing HTML and JavaScript, it's going to be kind of challenging to pull these off. And since this is a beginner course, I'm not really expecting any software developers to be in here wondering how to do a cross-site scripting, because if you're a developer, you're going to already know, because you will have had to write code to defend against it. Okay, we are going to come back to Portswigger, and we're just going to do a few of these just so you get an idea of how cross-site scripting works and how people can attack it, and just a little more understanding of seeing these in context of how they relate to pulling off these vulnerabilities, especially to beginners, as you can just copy and paste some of these into search engines and search bars, and you will see them on HackerOne in the Hacktivity, and just so you understand what's going on. So we'll go ahead and open up this first lab here, and we will be told what we are supposed to do. So we're supposed to call the alert function in order to solve the lab. And this one is going to be one of the most basic cross-site scriptings that we're going to see. And one of the common ways to check to see if a website or a web application has any defense against cross-site scripting in a search bar like this. What you can do is you can come in here, and this is basic JavaScript. So we just type in script, and then we type alert 1, and then we close the script tag. So this is just a basic JavaScript command here I can type. And so if this has no sanitization, then this should work. And you can try these in search bars. You can try them and post this script to any kind of social media outlet for the web application and see if it pulls back any cross-site scripting. So we'll go ahead and search this, and it says we have timed out because I opened the lab before I started this video. So we'll go ahead and reopen the lab and let that load. And we'll go ahead, and once this is loaded, I will actually just paste that in. Go ahead and paste that in, and we'll search it. And it pulls back the alert. We were able to alert 1, and it says we have solved this challenge. Now in the next challenge, we are going to go over the DOM cross-site scripting, which I actually think is down here, because this is one that we have seen with the inner HTML, this one right here. So if you would like to go ahead and open this up and give it a try and see if you can get this to pull the alert. We have looked at this payload before. It's not new to you. You will have seen it. You can go ahead and try and find it on your own. Okay, so how did you get along with that challenge? So we can actually come in here. This is the lab we're going to be working on. We can open it up, and we're going to be setting what we type in to the inner HTML, which means what we are typing in and searching for is going to be saved on the client side, which means it will try and render it. This is what I set up when we looked at the very first examples on the application that I tried to give you examples. If you go back and look at it, this says dangerously set inner HTML, which is just inner HTML with the React framework. And so this is going to be the exact same type of vulnerability that we have already witnessed at the beginning of this section on cross-site scripting. So you can go ahead and open up the lab, and we'll have our search bar, and we're going to be doing essentially the same thing we did in the beginning, where what we type in is going to be rendered on this page. And so we can type in our image, and then we'll do our source, which is where it's going to look for the source. You can actually type anything in here. And so it's going to look for a file saved in this application with this name, and it's not going to find it. And so that's going to cause an error. And what do we want to do? On error, we want to alert, and then here you would put your proof of concept, because we just want to prove that this works. And you can type in XSS, or you can type in 1, or you can type in whatever you want. And we will go ahead and close that off, and we can search this. And there is the alert for us. And so with that, that solves this lab. And we're going to try one more, and I'm going to show you kind of, this is a little more towards the intermediate level of cross-site scripting, but it's just a way for you to know more about cross-site scripting. And if you come across it and you really think there is a cross-site scripting vulnerability in a website, just how you can work through that and maybe do some more research on your own to try and exploit it. Okay, this next lab is going to be one that is going to give an example of what it looks like to start looking for cross-site scripting in a little more of an intermediate or advanced way. This is going to be probably the most common way that this is going to be found, because you're going to have to inspect the element and know how to break out of the HTML or the string that you're stuck in order to pull off JavaScript and run it within the application. So we're actually going to go ahead and open up this one right here, and it'll be over here. It'll tell us what we need to do, and we just need to break out of the JavaScript string and call the alert function. So I went ahead and opened this up, and the most common way to do something like this is type in something that you can remember what you typed, or something really easy to find. So we'll type in 1, 2, 3, 4, and we'll hit search. And now what we'll do is inspect the element, or you can view page source. We'll actually do that. That'll be a lot easier to see. So we'll view page source, and then we find our 1, 2, 3, 4, 5, but this is not where we're going to be breaking out of this. See, this is a script tag. The search term right here, we searched for 1, 2, 3, 4, 5, and we have the closing script tag here. So in order to close out of this, we can actually put a script tag up here in our search query, and it will close all this off. This script tag will match this script tag, and then we should be able to open up a new script tag, and it will run in the order. It'll run all of this in the order that it is laid out, and then we should be able to put in our payload. So we'll come back to our lab, and what we should be able to do is close off the previous script tag. So that will close this tag, and everything before it will be inside that tag. And then we should be able to come in here and type in our own payload. And so we'll go script alert, and we will just alert 1, and then we can close off our payload. And look at it, make sure it looks right. And that should work. And then we'll go ahead and search it. And there is the alert, which means we've solved the challenge. And everything after that script tag will get rendered on the page because it doesn't have an opening tag. If you're wondering why this showed up. So we'll go ahead and we'll look at the page source, and I'll show you the difference. See, here is where we closed off that script tag, and then here we put in our payload, and then because this script doesn't have an opening tag, this just gets rendered on the page as plain HTML. So if you are unfamiliar with programming, this probably doesn't make a whole lot of sense to you, but when it comes to cross-site scripting, it's kind of going to be necessary to understand HTML and basic JavaScript in order to pull this off. But the reason I included this in this beginner course is because cross-site scripting is one of the most common vulnerabilities, and so I wanted you to be aware of it, and maybe you can practice it and see if you can get better, or if you want to, before you take the intermediate course, is go learn some basic HTML and some basic JavaScript. It won't take long. You can learn HTML in a week. You can learn CSS, which is how to make a website look pretty, in a very short amount of time, a couple of days, and then you can learn basic JavaScript probably in another week. It doesn't take long. It's pretty simple to learn. And so I wanted to show you cross-site scripting. I want you to be aware of it. Like, look at how many cross-site scripting labs exist on Portswigger, and I think they actually have, DOM vulnerabilities, so even more cross-site scripting. So there's a bunch of cross-site scripting. It's really common, but it does take some programming knowledge to solve. And so with that, I will see you in the next video.
Comes next is usually the question of what kind of programming do I need to know. So in this video, what we're going to cover is the Python that I think you need to know as you're entering into cybersecurity. This is an introductory course into Python for the purpose of cybersecurity. I have tried to keep it as streamlined as possible to keep you away from having to watch a 6-hour course on Python for cybersecurity that is just full of stuff that I think you're not really going to need in the future. So this is a beginner course, and if you have any questions as you're going through it, please leave some questions down in the comments. Decided to go ahead and show you guys how to install PyCharm on your Linux VM. If you have a Mac or Windows, it's really straightforward. You just go to the JetBrains, you download PyCharm. I'll have this link in the description, and you'll click Windows, Mac, or Linux, and then you'll just hit download, and it will automatically start to download unless you're on Linux. So I have had to do this for several virtual machines that I've had. It won't download, and so what you have to do is right click the direct link, and you'll copy link. Then you will go to your terminal and you'll run a wget wherever you want this file to be saved. So if you want its own PyCharm folder, put it in its own PyCharm folder. For me, it is in my downloads, and you can save it wherever you want. You'll hit enter. This might take a little bit depending on your speed, your internet speed, and then you're going to unzip it wherever you downloaded it with this command right here, and then it will unzip. A bunch of files will come out, and then you will be able to CD into the folder. So for me, I will CD into my downloads because that's where it is, and then I'll go into PyCharm, and then I'll ls inside here, and I'll go into my bin, And then this is the executable I want to launch in order to launch PyCharm. So I will type in bash, and then I will type in pycharm.sh, and it will automatically launch PyCharm for me. So this is how you get PyCharm on Linux if you are wanting it on your Linux. I usually write everything on my Mac, and then if I need to run the code over on Linux, I will pull it over to my Linux machine and run it over here. So with that, we will get started in the next section. All right, we are ready to start our Python course. So we're going to start out very simply with a string. A string is a sentence that is a data type. So we're going to have several different data types coming up, but a string looks very simple. It is what I think of as a sentence in English. So you just have hello world. A string is always going to be stored inside of quotations. So if we were to print this, it would print right here, hello world for us. And if we change it, it's going to change along with us. So this is really simply, this is a string, and we can store strings inside variables, which is going to be coming up in the next section. But first, before we go on, you will see sometimes that you need a string on a new line, especially if you're going to export something into a CSV file. You're going to want things on new lines, and at the end of your string you can type something like this and then say hello world number 2, and then we can print this, and we have hello world and hello world number 2. And if I wanted to get rid of that space, I would do it this way. So we have hello world and hello world number 2. Another way to go about printing this would be like this. So print, and then we put our quotations and we say hello, and then we can add this like this, hello world, just like that. And now if we were to print it, we have hello world number 2, and then hello world. You see how there's no space right here? This is something that I run into regularly, and I just had happen the other day. There's 2 different ways you can put a space right here, and I'm going to show you the easiest way first is just to add a space right there, rerun it, and now you have a space. But I think it's helpful to know more than one way to do this. So you can add another quotation and put a space in there and add another plus sign. So you can run it this way and you still have that space. And it's really important to know this right here, because sometimes you'll be running a for loop and everything is just smashed together and you want a space in there, and you can add spaces simply just by doing this. So what I'm showing you right now, you may be thinking this is not ever going to be helpful, and I wouldn't be showing it to you if this wasn't helpful, and it's something you're going to run into in the future. So this is a very streamlined course, and I'm showing you just what you need to know in the world of cybersecurity. Now we're going to be covering something called a variable, and a variable holds the place of some kind of data that we're going to want to use later. So we'll go ahead and comment this out, and on a Mac it is command and then question mark. And so we'll comment that out. So now if we run our program, there's no output. And we're going to look at a variable. So a variable can be something like this, name, and then the name Jim. This name is going to hold whatever is right here. So this is our variable, which is going to represent the name Jim. So if we come down here and we print, and then we type in name, and then we run this, it's going to print what is stored inside this variable. When we look at variables, one of the things you're going to want to be able to do, especially in the world of cybersecurity, if you ever want to write your own tool, is you're going to be saving variables, only they're going to be input variables. So if we were to go like this and we say name equals input, and then we type what is your name, and then we'll want a space right here. So when we type in the prompt, it has a space. We'll comment this out, and then we'll print name. So we're going to print the variable, whatever the user inputs here. So now we can say, what is your name? And we can say Tom. And when we hit enter, it prints Tom. And there's something else that's really cool that I use all the time. It's called an F string. And what you do is you add an F at the beginning of your string, but you can print variables inside your string. So we'll go ahead and put name inside here. And so we can say hello and then the name. So we'll say run this. What is your name? Tim. And it puts out hello Tim. So this is an F string. This is something you're going to want to know. This is something I use all the time. And in the next coming up videos, we're going to look at data types and how we can pull information out of a specific string. And this becomes really useful whenever you run a script on a victim machine or on your target machine or your target server. You may get a lot of output that you don't really need, and this is a good way to start extracting data. So we'll start that here in just a moment. Okay, it is time to draw out some information from our string. So what we can do here is we can save a variable, and we'll call this variable name, and we can put inside of our name Tommy. So we have Tommy here, and let's say we want to grab just this M right here. What we can do with this is we can say print. We want to print our name, and then we add some square brackets just like this. And when you're running Python, it always starts at 0. So it goes 0, 1, 2. And so that first M is going to be 2, just like this. And so if we run this, it's going to print that M for us. And just to show you, if we want to print the T, we would enter a 0 here. And this is one of the most basic ways to draw out information. And it's going to get a lot more complex as we go, but this is what the square brackets do when you see them. And when we start to tackle lists and arrays, these square brackets become a really useful tool to remember. So as we continue to go through this, I want to pause right here, and I want you to go ahead and play around in your own text editor and make some print statements, make them on new lines, add in some spaces, make some inputs, and actually practice gathering information, and maybe have 2 or 3 inputs and have it print things back and forth, and you have a little conversation with your text editor. So I want to go ahead and give you this challenge for you to go ahead and play around with the things you've learned so far and try and really ingrain this information into your mind. These are the foundations of Python programming, and you need to know and understand how they work. You're going to notice is you can name variables whatever you want. And I name my variables really poorly, mostly because the programs I write for myself, and I am not working with a team of developers, but maybe you will someday. And when you name your variables, you can name them whatever you want. And you'll want to make them names so other people can understand what is going on. So if you look at some of the code I've written in past videos, I do this right here. I name everything like this. And it is not really the best way to go about naming these. So I'll name one guy 1, and I'll go guy 2, and he'll equal Bob, and then I'll come down here and I'll print guy 2. And then I run this, and then I have Tim and Bob. You can name variables whatever you want. Literally, you can go whatever I want. And you can make this a variable, and then you can come down here and you can print whatever you want right there. And you can name variables whatever you want. So I would recommend getting in a good habit of making your variables something that you can recognize. And it's a very bad habit that I have, because I make my variables so that people cannot read what I have done. So this is something I'm trying to get better at, but I probably won't, because this is a bad habit that has formed over many years. But I want you to have a good habit of naming your variables something that you can understand and other people's can understand. So as you go through and work through your challenge, try to name your variables different things that you will be able to understand in 6 months after you have written a program and you need to go back and edit it. Okay, I have created this little challenge here for you. If you want, you can go ahead and pause the video and open up your text editor and see if you can create this little program right here. So we want to, one, create an input with a greeting. So just say, hello, what is your favorite food? Let them put it in, and then take another input and say, what is your favorite hobby? And store that also in a variable. And then we're going to print with an F string their favorite food and their hobby. So if you want to give this a go, you can go ahead and give it a try. If not, we will start it now. So we're going to start out with create an input with a greeting. So we'll just say print hello. And then we're going to take an input, but we got to save it as a variable. So we'll save this as food, and it's going to equal an input. And inside the input, we're going to have the question, what is your favorite food? Question mark, space. I see that we have a typo here on all three. And then that's going to be saved as their food. Then we're going to say input, and this is going to be, we'll just save this as hobby, and we're going to take in input, and we're going to say, what is your favorite hobby? Question mark, space. And then we're going to print with an F string all of this together, and we'll say print your favorite food is, and then if you remember, we need our F string here, and we should grab our curly braces and say food and your favorite hobby is curly braces hobby. Now when we run this, if we did everything right, it should print for us this final statement after we give these inputs. So we say run, and it says, hello, what is your favorite food? And we'll just say chips. What is your favorite hobby? Running. And it says your favorite food is chips and your favorite hobby is running. So this is a simple input form, and it's going to print out with our variables that we have stored. And this is a good practice because when you write a program for a tool maybe that you develop in the future, you are going to want to know how to do inputs, so that way you can take the input, save it in a variable, and then later do something with it. So later on in the course, I'm going to give you a practical example of taking input and then running it in a program that is really helpful, and I will cover that when we are ready for it. All right, so we have covered the string so far. This integer is a whole number. So if we say int, we have a number of 7. Floats, we're not really going to use these a whole lot in the world of cybersecurity. They have a point within the number, so 3.14 would be an example of a float. To date, I cannot remember a single time I have used a float in cybersecurity. Usually that's more towards data science or something of that nature. A Boolean is true, false. You will want to remember Boolean. We'll cover these a bit in the future. When we do our while loops, we'll be using the true, false. So these are some of the different data types. And just to get an idea of what these look like, if we save a variable and we make it a float and we say like 1, 2, 3, and then we print this, it will tell us what we have. So we can come down here and we can say print, and then we can put type, and then we can put in our variable. And when we run this, it will tell us that we have a float. And if we put in an integer, it will tell us that we have an integer, and then so on and so forth. We can do this with an int, and then we can also do this with a string. And we can hit run, and it tells us we have a string. Sometimes we will do something like this, and then we have this saved as a string here, and then when we go to add this to something else, we can get an error, and it's because we have a string and we'll be trying to add together a string and a integer, and it won't work. So we'll go variable 2 equals 3, and then when we say variable 3 equals variable 1 plus variable 2, we're going to get an error, and it's going to tell us that you can't add these together. So this is one version of how these matter. Another version of this is, let's say we want to print, and we say we have an integer right here, and we want to add it to a string, and we can go like this, and we say 70. What do you think is going to happen? It tells us we can't add these together. But if we take this and we turn this into an integer, what will happen now? Now it works. So this is the difference. So this is an integer, this is a string, unless we declare it to be an integer. And you can do the same thing with floats, so I'm not going to cover those. And then what happens if we do this right here? What do you think the output will be? And the answer is 7070. So this is the difference between integers and strings and how they work with numbers and data. So if we wanted to, we can turn both of these into integers. And this is the last example. I promise I don't want to bore you with adding these together. And then we say enter, and we're back to 140. So this is a little bit of strings, integers, and booleans, and we'll kind of skip floats because I don't think we'll really need them, but it's worth mentioning so you know they're here. And with that, we will continue on with our next challenge. Okay, so we have these numbers here, number 1, 2, 3, 4, 5, saved as num1, and then num2, and then num3. What I want you to do is to write this to your console, or write this to your text editor, and then I want you to add this variable plus this variable and see what the output is. And then I want you to take the second number in num1, so it would be this 2 right here, and I want you to add it to the second number in num3, which is this 7. So your output should be 9. I want to see if you can figure that out. And then the third challenge is to take num2 and change num2 into a float and print the type to the console, so that way the console tells us that it is a float. So if you'd like to go ahead and pause and give this a try, you can do that now, or we will go ahead and tackle this right now together. So what we are going to do just first is we're just going to print, and we're going to say we're going to turn this into an integer, and we're going to go and write in num1, and then we'll add this as an integer, and then we will say num2, and this needs to be closed off or we will get an error, and this should print it for us. So it tells us here is the total if we add those together. And then the second challenge is to add the second number. So we'll just take this, just a heads up, copy and paste. In programming is always a bad idea, because if I have a bug here, I just now copied and pasted it and I have 2 of them. But what we're going to do is we're going to take this and we're going to put in our square brackets. And if you remember, it says 0, 1. So we're going to say 1, and then we're going to say 1. I guess I didn't really need this. And then we'll print this, and our output is 9. So now we've grabbed the second numbers. And then our third challenge is to change number 2 into a float so that it prints float. So what we want to do here is just say print, and then we're going to tell it we want a type, and we want to print out the type of num2, and then above that we're going to just type in num2. You can do this 2 different ways. I'm going to do it this way. I'm going to say num2 equals
num2, and we'll just go like this, and we'll type float, and we'll close this off. And now if we print this, it tells us it is a float. And we will continue on with our Python course in the next section. Okay, we are going to do a walkthrough of if, elif, and else statements. So this is the instructions for the little program I'm going to write. But when I finish this program, I'm going to give you a challenge to do something similar on your own. So I'm only going to give one example. You're going to need to pay attention and maybe watch this walkthrough twice, and then go on and try the challenge. So the first thing we're going to do is if you are under 5, you are a kid. So our if statement is going to first need an input from the user that is going to tell us what is their age. So we'll just say we have a variable and we want it to be an integer, and we want an input, and we're going to ask them, what is your age? Question mark, space, and we have to have that space, otherwise it's really ugly in the terminal. And then we're going to start our if statement. So we're going to say if this person's, their input, which is their variable, is less than the age of 5, then we want it to print that they are a kid. So we'll print, you are a kid. Now, one thing we want to do is if they hit the age of 5, we'll need an equal sign here. Otherwise, I'll just show you. If we say, we'll need an else statement so this doesn't error out. Actually, we'll just let it error out. We'll say, what is your age? And they say 5. And we get no output because this doesn't include 5, remembering that the computer starts at 0 and then it's going to stop at 4. So if we want to include 5 in as yours a kid, we'll need that the variable is less than or equal to 5. Now, if we put the 5 in here, it will print for us, you are a kid. So what we need to do next is we're going to type in elif, because we're going to make an elif statement, and we're going to say the variable is less than 15. And the reason we don't have to worry about anything under 5 is because it will catch this if statement, and then this whole program we write after this will stop and the computer will actually skip it. So we don't need to worry about adding anything else in here. And we can say, actually, if you are less than or equal to 15, then we are going to print you are a big kid. And then for the final elif, we will say the variable, and we will say if it is greater than or equal to 21, and that's ugly, and we will say print, and we're going to print you are a bigger kid. And now we're going to put in an else statement, and in our else statement we're going to print anything that's over 21. We're just going to print you are old. So now if we run this and we rerun the program, we run it and we say how old are you, and we say 3, we get your kid. If we say 13, we get your big kid. If we say 18, we see you're a bigger kid. And if we say you are 44, we get you are old. Now, because we're going to be using this as a tool for us to be able to write tools and modify tools, I'm not going to cover this because I think that it's not really necessary for cybersecurity. But if somebody were to run this and they put in the letter A, it's going to crash our program because the letter A is not a number. It's not an integer. So what we'd have to do is we would have to make this so that if they put this in and it was an A, it would print, enter a number, and then rerun. But we're not going to do that because it's not really necessary for cybersecurity. It's just something to be aware about. Now, what's coming up is your challenge. Let me delete all this and I will write up your challenge for you in the next section.
Your challenge here is to take the temperature from the user and then tell them if it is less than 20 degrees, you need boots. And this is from the US, so I'm running in Fahrenheit, not Celsius. And if it's less than 30, you will need a coat. If it's less than 70, you will need a jacket. If it's over 70, it is nice outside. So take this input or take this information and make a program with if, elif, and else statements. Okay, so here is how I would go about doing this. I would take an input and it will say, what is the temp outside? And this will need to be an integer because we're going to be comparing this as a number. So we'll say if var is less than 20, then we're going to print you need boots. And we'll say elif var is less than 30, print you need a coat. And then we're going to use one more elif here. Elif var is less than 70, print you need a jacket. And then finally we'll do else, and it's above 70, then it's nice out, and we don't actually need to put anything in there because this is an else statement. So everything that's above 70 will automatically print it is nice outside. So when we run this, if we put 12, we need boots. If it's 22, we need a coat. And if it is 65, we need a jacket. And if it's 85, in my opinion, it's perfect outside. So this is the if and the elif and the else statements. We're going to be moving into for loops, and later we're going to look at nested if statements, and they'll look something like this. If it's less than 20, and then we can say if var is less than, we'll say it's greater than 25, then we can print you need boots, and then we'll print something like gloves. So nested if statements look something like this, and you can have nested if statements just so you're aware of it. So if we say it's 26, it will, because we're hitting this one, we'll say this is 15. So if we say that the temperature is 16, we hit you need gloves and you will need boots. So this is a nested if statement. We'll cover these a little more in the future. I don't know how much you will need these nested if statements. I use them every now and then, so it's nice to know that you can run nested if statements. But for now, we're going to move on to our for loops. Before we get into for loops too far, I want to show you why for loops are important, and I also want to show you why lists are important, which we're going to be going over here in just a minute after we get the basic understanding of a for loop. So this is a program. I've shown it before. Don't worry about what it looks like. It looks kind of complicated, but it's really not. What happens is you put in a repo that you would like to target on GitHub to go and search for all of the usernames, passwords, and files that just shouldn't be made to the public. So in this case, it's looking for passwords on GitHub. But what we have down here is a for loop. So this for loop right here, we have an empty list, which we're going to cover in a second, and it goes out to GitHub right here, and it will go through all these links, everything you can click on, and it's going to narrow it all the way down to the repositories, and it will click this link, and then it'll click the file, and then it will click the raw, then it copies this entire thing, and it puts it into a CSV file, and then checks for the word password. So that's the program itself. But what's important to remember is what happens is it goes out and it pulls all the links and puts them in a list. Then it goes through this for loop and it takes all of these, and it says for every one of these items that is inside of the links, which is actually this variable that I have up top, it's going to do something. So for loops are very important. You can see I have another one right here. So for loops, we are going to need them. Lists, you are going to need them as well. And I just wanted to show you this because sometimes what happens is you'll be going through trying to learn something, and I'm showing you something very elementary, and you are like, why do I need to know a program that tells me to put on a jacket? This is all building up to something that is going to be able to help you build tools, and more specifically, if you're new, just be able to read through exploits and be able to edit them, because you're going to need to know how to read Python and edit exploits as you grow in the world of cybersecurity. So here is a very basic for loop. And I'm going to show you it in a string because we've already covered strings. And what all this does is we have our variable string right here that is holding hello world. And so the way the for loop works is it says for I in string. So this I right here is going to be another variable that holds one letter each time the for loop runs. This I is going to represent one letter, and in a list it's going to represent each item in the list. So this will run. I'm going to run it so you can see what this looks like. The way it runs is it goes for I in string, so it's going to grab the first letter, which is going to be the H, and then it prints it. But the for loop is not over, so it runs the loop again, and it'll grab the E, and it'll print just the E on a new line, and then it goes through and it runs every single time until it is out of things to run, and then it closes the loop. So this is how for loops work. I'd like for you to go ahead and write out your own for loop and maybe put something different in here and try to get an understanding of how it works. And if we wanted this to print all of this together, you would have to store this into a new variable and then print it outside the for loop down here like this. And this is where we would print our new variable. And we're going to cover this in lists because this is something that you will need to do in the future. So go ahead, play around with the for loop, write one, get an understanding of how it works. If this doesn't make sense, rewatch it, and hopefully it makes sense. I know after teaching for loops to several different students that for loops sometimes can be hard to understand, but they are really useful and something you need to learn. So we're going to be covering lists in the next section. We're going to be looking at lists, and a list is something that is going to be useful because we're going to be appending to lists all the time within our for loops. So a list can look like this. My list equals square bracket, and lists always go inside of square brackets, and we can say item 1 and then comma item 2, and then we can do an item 3. So we have our list here, and if we want to run a for loop through this list, we will say for I in my list print I. And now if we run this, it will run item 1, item 2, item 3. So this is a list. We will be using these in the coming lessons, and they will be helpful for you in the future. As you've seen in this program, I have 2 lists right here, and they are used regularly to append to. So lists is something you will need to know. So go ahead, make your own list and see if you can loop through your list, and maybe try and just print something like this later. Just print the item 2, so you'll have item 1, 2, 3, and then print number 2, and see if you can remember how to do that. If you have forgotten, it would look something like this. Print, and then we can say my list, and then we can put this in square brackets, and we'd say 0, 1, and then we have a 1, and now we could print this, and we have 1, 2, 3, 2. So that is going to be it for the lists. We're going to move on, and we're going to start using lists in a more comprehensive manner. So we're going to try a while loop now, and the way we're going to do a while loop is by using a Boolean. I like to set a variable and then set it to true, and then at the end of the while loop I will set it to false. So the way this works is make a variable, and we'll just say variable, actually we'll name it on. That's a good way to name the variable, and we'll say on equals true, and then we'll say while on, and we'll make a variable, and we'll just call it variable because I don't know what to name it, and we will take an input, and we will say continue running while loop, and then we will put y, we'll put a y or a no. So would you like the while loop to continue, yes or no? And then we can say that we can go do something like this, and then we can set a variable up here and say I equals 0, just so you can see how many times this is running, and then we'll say I plus equals 1, and then this should just continue to run, and then we'll put an if statement, say if the variable equals in, then we'll say that on equals false, and this will kill our for loop. So now if we run this, it'll say would you continue running the while loop, and we will say yes, 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 and then when we say no, it'll kill the while loop. I forgot to print our I so that we could see this. So now we can say, would you like to continue? Yes, yes, and you can see our variable, every time the for loop runs, our I gets added to 1. So our for loop has run, now it says 7 times, 8 times, 9, 10, and then when we're done, we can say no, and we can end it. Okay, we are going to be starting functions, and just to be clear, I have not pre-written any of the code we're about to go over, or mostly anything we've gone through in this course. That's why you've seen me make mistakes. And so as we start functions, I'm going to try and make this a little more realistic for us, so that when we are thinking through functions and writing code in the realm of cybersecurity, you can start to get an idea of how this can be used. So we're going to start with functions, and a function just calls something very specific that we want to happen. So we can just say, we'll call it my function, and then the way your function is going to start is with a def my function, and then we close it off like this. And then down here, we want our function to do something very specific. So we can say print, and then we can say it worked. And the way a function gets called is usually somewhere further down inside the code, something happens and it triggers this function back up above it for it to actually do something. So what would happen in order to call this is we would just say my function. Now when we run this, when the computer reaches this right here, this closing bracket right here, I usually like to think of this as the call sign for the function. So if we run this, it's going to print it worked. And this will become more clear as we write more of these, but this is the basic concept of functions. And one thing we can do with functions is we can pass through variables. So we can say something along the lines of I, and then we can say I, or we'll make it a different variable. We'll say variable equals I plus 3, and then we can say print, and then we can say we want to print our variable. And so in our function, we can pass information through like this. So when we say my function, we can now say input, and then we can say, what would you like to add? And because this is a string, we're going to need to make this into an integer. I guess we can go and make it an integer right here, and we can say int. And then we can close this off. Now when we run this, it's going to ask us what would we like to add, and we can say 3, enter, and it'll say 3 plus 3 equals 6. So this is a very basic function. So we take some kind of input right here. This is where we call our function. So now this function is being triggered, but we want to pass something into our function, some kind of variable or some kind of information that we've grabbed somewhere else. And what happens is it can now use this inside the function. This, you may be thinking, like, in what case would I possibly ever need to use this? And so I'm going to just show you my GitHub dumpster diving tool, once again, that I've used multiple times on this channel. This right here, where it's grabbed a repo, I call this function, and it's going to loop through to see every single file inside of the repo. Is it a Python file? Is it a JavaScript file? Is it an XML file? And what happens is when I pass this repo through, it now is able to use this variable that has come from somewhere else inside this function. And then I do the same thing up here. I pass through a variable inside of a function. So this is really important to know, and you will use it. And we're going to go ahead and give another example. And actually, before we give another example, I want you to try and write your own function and see if you can get it to take an input. So let's take the input and make it the first letter of your name. So I'll write out the instructions. You want the, we'll say, first letter of your name, and you want to take this as an input. So we'll say input, and then you want to call a function that adds your first letter to the rest of your name. So here's your instructions. You're going to make a function, and then it's going to take a variable, and that variable is going to be the first letter of your name, and then you're going to add that to the rest of your name. So I hope this makes sense, and I'll go ahead and walk you through what this would look like. So we'll go def my function, and then we're going to call this function. We're going to pass through, let's use I as our variable, so that stops giving us, whenever this is giving us an error and I can't stand looking at it, I type in pass, and that will not give us the error, and we'll come back and delete that in a second. And we're going to call my function, and we're going to take another input, and we're going to say what is the first letter of your name, question mark. Now we can delete this, and we're going to come back up here, and we're going to use this, and we're going to say that my function, and we're going to take this input, and it's going to be a pass through as I. And so down here, we're just going to say my first name is Ryan. So we will say I, we'll call it the variable equals I plus,
and then we can put the rest of this inside of a string, and we can say something like this, and then we can print our variable. So when we run this, if I put an R in here, it'll print out my name. So I hope you're able to figure this out. Maybe try to come up with another way to write a function and practice writing functions and see if you can get the hang of it. And in the next section, we're going to go over something that will show you how this can be really helpful in building your own tool. Okay, I hope you have played around with functions and you are now ready to try and become a little more advanced, and we're going to try and gear it towards cybersecurity now. And I hope you're familiar with maybe the Nmap scan and some other tools. So we'll just use an Nmap scan right now, and we'll just say, like, we're going to call a function and we'll call it Nmap, and this is going to take a variable, and we'll actually call it the IP because we're going to take an IP address. And the way I like to run my Nmap scans is with they'll look something like this: Nmap -a, like this, and then we're going to pass in the IP address, and then I like it to be verbose. Now, in order to get this to run, we would have to import a module called OS, but we're not ready for that. So this is just to show you how the functions will work. And so I will wrap this entire thing inside of curly braces. I got dashes in here that shouldn't be there. I don't know why I did that. And then we'll wrap this inside curly braces. This is not supposed to be inside curly braces. That is supposed to be inside of quotes. We'll make this an F string, and we'll say our variable equals. Instead, this would be an OS command if we were actually going to run this in our Linux machine or Windows, whatever you choose to use as your hacking VM. And now what we'd do is we'd come down here and we would say something like Nmap to call our function, and then we're going to take an input and we're going to say, what IP would you like to scan? And then right here we are going to print running Nmap scan against, and then we will put in the IP address, and this will need to be an F string. So the way this, that will not be the IP. That will be against the variable. So it will tell us that it is running the Nmap scan right here. Okay, so when we run this, we can say who would we like to scan against, and we'd say 192.168 point something else. And then when we run this, it'll print running Nmap scan against, and then it gives us the output right here. So this would be a way that if you were trying to write your own tool to automate your recon, this would be one of those ways you would use a function in order to automate your recon. And there's a lot more you can do with this IP address, and you could pass it into multiple different tools, and then you have written your own tool. So this is how we can use functions in cybersecurity that are really helpful for us. And whenever you're going for a certification, it'll be really helpful for you to be able to read through functions and maybe modify them, especially in exploits, because vulnerabilities and exploits change over time, and you will need to be able to change and modify different exploits that you come across on Google in order to gain access to a machine. Before we end this course, I want to give you a little bit of an introduction into making your own tools, and then I want to challenge you to add to this recon tool that I'm about to show you, and you can start to build your own tool for recon, and it'll help you remember the Python code that we've gone over so far in this course. So I've gone ahead and connected to HackTheBox and launched the box devel, and so I want to just show you what OS system does. So we'll import
OS system. You've seen this before, and this is just our operating system. It just means we're going to be able to tell our Linux machine to carry out commands the exact same way you would inside of a terminal. So we're going to make a function, and we're going to call it recon, and we're going to pass through an IP address. Really, if you remember, this is just a variable that we're going to be passing through into the function, and then we're going to call our function down here, and we'll just call it recon, and then we're going to ask for an input, and then we're going to say, what IP would you like to scan? And then we'll put a question mark and a space there so that way it's not all smashed together. And now inside of here, what we can do to make this program run our recon and automate it for us is we can type OS system, and then we can put in here, we're going to make this an F string, what we want to do. So we're going to run an in-map scan, and we're going to run it on all we're going to want all outputs. We're going to run it on all ports, and just in case it is blocking the ping, we'll put the P in. You don't have to put this in here, it's optional. And then we are going to put in the IP address that we run through, and I really like to run everything as verbose. So this, when we run this, you'll be able to see, it'll say what IP would you like to scan, and I'll put in the IP address, and it will now start the scan for us. So this is the same thing we would see inside the terminal. We're going to see port 80, port 21 is open, and at the end of the scan, it will tell us everything that has happened on this scan. Now you can add to this, we'll stop this, you can add to this same scan. When it gets done running the in-map scan, you can come down here and maybe you want to look for different directories, and so you could go os.system, and we're going to make an F string, and we can add in, maybe we want it to run derb, and we want it to run on the same IP address that we've already passed in, and it will now launch this right here as soon as it gets done with nmap. And the cool thing about this is if you have your own recon tool set up, you can go ahead and run the program, send over the IP address, and then you can leave and it will automatically run your recon. Or maybe while your recon tool is running, you can do other more manual enumeration. Maybe it has port 80 open and you see that real quick with the nmap scan, and you want to start looking at what's on port 80, and it will run your nmap scan, it will run your dirbuster for you, and maybe you want to run wfuzz, or maybe you want to run sublister. I want you to go ahead and start off with what I have given you right here, and you can add to this tool with the information that you have learned so far.
Okay, so in this video we're going to be covering enumerating APIs or backend APIs, and I see this in bug bounty programs sometimes, and I'm sure you guys have come across a page that looks exactly like this. You come in, you go to the URL, and you get some JSON in return. And I actually was looking through a bug bounty program just a few days ago, and I actually saw it said backend and then api.theprogram.com. And so if you're new and you're not really sure how to enumerate APIs, then this video is going to be for you. We're going to keep it really short and specific so that way you can go out and do this yourself. We're going to be looking at the Box backend on Hack the Box, but we're not actually going to walk through the box. I just want to show you how to enumerate APIs, because this is something that isn't covered in any courses or any certifications that I know of. So if you come in to your terminal and you have an API like this, and you come in here and you type in like V1, or you're typing in basically anything, you're just trying to figure out how do you get further down the line, you're looking for endpoints. The tool I like to use for API fuzzing is Fuff. So it looks just like this. If I can get here, Fuff, there we go. And I actually ran this just to make sure it was going to work before I did the video. So I like to run Fuff, and then you give it the URL, and this is the API, and then we're going to be fuzzing for an endpoint, and then you give it a word list that you want to use. GoBuster and Derb and a lot of those
your usual fuzzing tools just don't work with API. So I like Fuff because it does work. And you run this and you see it pulls down docs and API. So if you were to do this like in a live program, you'd come in here and you just type in API, and then it says we have V1. So you can just type in V1, and then you'll have user, and you can kind of see if we wanted to look for more endpoints, we could just close out of this and we would just move our fuzzer over. So you would just go like this, and then it would fuzz right here, and it would look for more endpoints over on this point. So that's how this fuzzing APIs work. If you're interested, you can go ahead and do the box, hack the box. It's actually really simple. You just create a username using the API. So you'll use burp, you'll just intercept the request, and it'll send you back a JSON of what you need, and then you can turn your request into a post request and make a username and password and log in. So this is API fuzzing. You'll see these on bug bounty programs, and sometimes you'll come across them in hack the box machines, but this is something that's not really covered. So I wanted to make a quick video on API fuzzing and bug bounties. So sometimes you can find an API URL like this, and you can just start fuzzing away and see what information you can come back with and manipulating the request. So that is API fuzzing.